terminal.
The chamber pressure looks good.
Throttling up. Roger, roll, Atlantic.
Water towers can fly! Yes!
Tango Delta nominal.
Flight down, SC off. Say again, SC off.
Yikes. You bet. Concur. We don't need any more of these.
Hello, everybody, and welcome to NASA Spaceflight's live coverage of the Artemis 1 wet dress rehearsal. You are looking at a live view of Launch Complex 39B with an SLS rocket that is almost completely fueled now, as NASA and Boeing and all of the other contractors involved with SLS are working towards that, of course, all-important Artemis 1 test flight. My name is Thomas Burkhardt. I'm the news director here for NASA Spaceflight. Thank you all for tuning in for today's coverage. The teams have been working for actually a couple days now, working on today's wet dress rehearsal, but we are now into the propellant loading operations of that test. And that is when we are spooling up our coverage to give you updates as the teams get closer and closer to the actual terminal count, which is, of course, the business end of the wet dress rehearsal. I am not alone on commentary today. I am joined by a few folks. First and foremost, out in the field, we have Mr. Chris Gebhardt, Assistant Managing Editor for NASA Spaceflight. Chris, how you doing out there?
I am doing just fine. I'm in my happy place, and there's a fueled good orange rocket on the pad. So we're doing good. We're doing good.
Sounds like a pleasant afternoon. Chris, thanks for rolling out there today. Also joining us on commentary, we have our resident orange rocket expert, Mr. Philip Sloss. Philip, how you doing today?
I'm doing mega good today.
Mega good for the Mega Moon rocket, and that's the last
Right.
time I'm going to say that phrase today because I find it
I don't
annoying,
mega know. We'll see. We'll mega see.
But thank you all so much for joining us. Of everyone who has tuned in, as you know, we like to take your questions over the course of the broadcast. So if you've got questions about today's testing, tag us at NASA Spaceflight in chat, and we're going to get as many of those answered as we can over the course of the coverage. Right now, let's start with a status update as to where they are in the testing. We mentioned that the core stage, which is that first stage powered by those 4 RS-25 engines we're getting such a good view of right now, is completely filled with liquid hydrogen and liquid oxygen. And the upper stage, the interim cryogenic propulsion stage, or ICPS, which is powered by a single RL-10 engine. It's basically a Delta IV upper stage. That stage is almost completely filled. It's got the liquid oxygen completely filled, and they're finishing up liquid hydrogen loading.
Other way.
See, I knew I was going to get that backwards. It's filled with liquid hydrogen and is almost done with liquid oxygen. Chris, Philip, where does that put us with regards to the terminal countdown and the remaining testing that they've got to accomplish today?
Well, I'll go really quick, and this will explain a little bit of your confusion there, Thomas. Overall, things went well. There was I think everyone groaned this morning when there was a nitrogen issue again, but they got through that very quickly. It was not the same nitrogen issue as before, and nitrogen has not been an overall issue for today. So those fixes that Air Liquide made in the intervening 2 months are definitely working, and we have a happy nitrogen supply to the vehicle. They then got into liquid oxygen chill down and then liquid oxygen loading for the core stage. And then once liquid oxygen loading was in fast fill, they transitioned over to start the liquid hydrogen chill down and then liquid hydrogen slow fill and then fast fill onto the core stage. And on SLS, you start loading the liquid oxygen first because of its density, and then you start loading the liquid hydrogen second, and you actually complete your liquid hydrogen loading first on the core stage, even though there's far more of it to pump into the core stage than oxygen, but you actually finish it first, even though oxygen starts flowing first. You do the exact opposite on the interim cryogenic propulsion stage, the modified Delta IV upper stage, like you were talking about, Thomas. You actually load the liquid hydrogen first and then the liquid oxygen. And liquid oxygen is where they kind of got into a problem. There were 3 issues that had popped up during fueling. One was a pressure exceedance. They reached the maximum pressure that they were allowed to while on a propellant line, while they were fueling the ICPS with liquid oxygen. They needed to stop, manually configure some things on that to get the pressure down. They were able to do that, and fueling is now underway again on the upper stage. But that is the liquid oxygen tank on the upper stage is all that is left to fuel. All other tanks, liquid hydrogen and liquid oxygen on the core stage, are fully fueled and in stable replenish, and liquid hydrogen is in stable replenish on the ICPS. The other two issues that they have encountered so far today is a small grass fire that ignited around the around the gaseous hydrogen flare stack, which might sound alarming, but isn't in this particular regard. The fire was very, very small, and actually, because of our wind direction, was burning toward a dirt road, and it was a very small fire. They only saw basically the smoke indication of it. We're not talking about huge flames or anything like that. And because it was burning toward a dirt road, they just decided to let it burn out because that's the safest thing to do in that regard. So not an issue there. And then there is a leak on the tail service mass liquid hydrogen line leading to and from the core stage, but it is not at the same place as the leak last time. So the leak last time was when they transitioned into fast fill, actually flowing propellants into the core stage. This is actually on a slightly different line. And I will let Philip take over here because he can explain engine bleed far better than I can. So Philip, take it away. What's leaking here?
Well, at least what we're getting is what they've said on the commentary today is that they're seeing a leak in a quick disconnect on the hydrogen side with the core stage. And so you have a tail service mast umbilical. There are two of them, one that's mostly liquid oxygen functions, which would be on the back side of this picture that we're looking at here, and then the liquid hydrogen one, which is in the foreground. And there are two main lines that run. One of them runs into the core stage, flowing liquid hydrogen into the core stage. That's the fill and drain line. That's an 8-inch diameter line. And then there's a line called a bleed line, which is 4 inches in diameter. And they have this system called the hazardous gas detection system, and that's telling them that they're getting hydrogen outside of the lines, which is what you don't want. You want it to stay inside the lines. And I think the reason that they're able to sort of narrow it down to one or two of those lines is because of the flow rates. The core stage liquid hydrogen tank was already in stable replenish, which just means there's a very small amount of hydrogen that's flowing into it to replace the boil off that's coming up at the top of the tank. So they're starting this engine chill down that Chris was talking about, and what that does is that runs liquid hydrogen through all of the main propulsion system lines in the core stage engine section, and also the engines themselves, because you're trying to temperature condition those that hardware down to the start conditions. They have to be at the right temperatures, and they were talking about this in the commentary. They said they have to do this engine bleed conditioning for 168 minutes, which would be, which is almost 3 hours long. So apparently, when they started that bleed and you had a high flow of hydrogen coming out of the vehicle through the quick disconnect, then they saw a spike in the hydrogen concentrations. And so they weren't real clear on whether, you have, it's a quick disconnect. And so you've got a ground side plate with all of the services that connect up to the core stage, and that separates at liftoff. You have valves on both sides. So they didn't distinguish whether this is a ground side valve or it's the vehicle side valve. Now they tanked this vehicle, the core stage, at Stennis 3 times, and I don't recall hearing any issues with it at Stennis. So, just process of elimination, and we could be wrong, but it seems like there's some sort of an issue with a valve that is not closing and seating correctly. And of course, liquid hydrogen is very cold, and it's possible that the sealing surface on the valve, the valve changes shape slightly because it's so cold when you go from room temperature to 423 degrees below 0 Fahrenheit. So what they're trying to do is they basically have sort of taken the flow off and around that bleed line to let it warm up. And I think they last time we heard, they said that they got the temperature all the way up to 60 degrees below 0 Fahrenheit, which is still 350 degree temperature swing. And then they're going to start chilling it down again. And hopefully what they're hoping is that somehow that will have the sort of warping of the valve, so to speak, that temperature conditioning, that temperature cycle, heating it up and then cooling it back down will somehow make the valve seat when it closes. But then, of course, the big question is, how much of that 168 minutes of engine conditioning do we still need to, let's say they fix it, how much of that time do we still have to go if we're going to try and set up to make this terminal countdown attempt, let alone 2 of them today.
So on that terminal, on the note of that terminal count, Philip, we're getting close. We're at a T-minus 11 minute mark, and I do want to address this because we're already getting a question in chat as well. The countdown clock that you're seeing is directly from the official NASA countdown feed, and so that's going to update automatically whenever any holds or anything occurs. And at T-minus 10 minutes, we are expecting the clock to stop. Is that correct, Philip?
Yes, that's correct. So originally we were going to go into this hold at T-minus 10 minutes, and it was supposed to be, normally it's only supposed to be 30 minutes long. At this point, we're waiting to hear from the NASA commentator and from the launch team about what they're going to do here. So we should see the clock hold at T-minus 10 minutes. And we talk about a 10-minute long terminal countdown phase. That doesn't begin until they pick up the clock again. If they pick up the clock again. That sounds like I can hear NASA. Yep.
10 minutes in 3, 2, 1. And we are now in a half-hour hold at T-minus 10 minutes and counting. This is a pre-planned hold. Gives the launch team an opportunity to catch up on any work that didn't get done, as well as see if they have enough time to make up before launch, or I should say the simulated T0 for launch. Here's the situation: the team that had that was working the hydrogen leak repressurized the line. This is the quick disconnect that is at the tail service mast umbilical on the core stage hydrogen side, and it did not work. They warmed the quick disconnect up and then chilled it back down, hoping that bull nose would reseat in the seal, and unfortunately it did not. Charlie Blackwell Thompson, launch director, has her team going back and trying to find out if there's another option for troubleshooting. They say that they've tried the one option that they knew of, but they're putting their heads together and seeing if they can come up with any other options to seal that leak. In the meantime, we are still in fast fill for the liquid oxygen tank on the upper stage. That continues to move forward with no issues. The team will also recalibrate the clock for a new T0. And we're awaiting that. When we have that, of course, we'll pass that along. But currently we are at T-minus 10 minutes and holding, awaiting more information on that hydrogen leak and what can be done about it. For now, this is Artemis Launch Control.
Okay, so that was an official update from NASA PAO. We'll bring those in as often as they bring them. But let's back up and clarify a couple things that have just happened. So like we were talking about, this was an expected hold at T-minus 10 minutes. Ideally, this is a 30-minute long hold that precedes the terminal countdown. So we had a question in chat about if this is a T-minus or an L-minus clock. This is a T-minus clock because the clock does have built-in holds even if the countdown is proceeding nominally. Of course, today this also isn't technically a launch countdown. It's a dress rehearsal countdown towards a simulated T0. But if it was launch day, that clock would still have built-in holds with it, and so it is a T-minus clock, not an L-minus clock. It does not sync up with the L-minus time until the final terminal count, which is 10 minutes before launch. So what just happened there is that official update saying that they were working to try and resolve that issue with the core stage quick disconnect, and it sounds like the attempt to reseat that seal was unsuccessful. Do you want to talk a little bit about what that means?
Yeah, in general, what they were talking about is that some ways that you can work with seals and get them to reseat themselves, so to speak, is to basically warm them up from cryogenic conditions. And that usually allows them to.
It looks like we might have lost Chris there for a second. Philip, you want to just talk us through what the effects of not being able to reseat that seal might be?
Well, if they cannot get it to reseat today, then we're probably not going to pick up the clock and try and do this terminal countdown test. So we'll see. But as we heard during the commentary, that was kind of their only major troubleshooting attempt that they can make without detanking and getting their hands on the hardware out there. But that, in order to do that, to get hands on it, they'd have to scrub, drain the tanks, inert the vehicle, which is probably not until tomorrow, and then they'd have to go out there and do some troubleshooting. So we'll see. It does sound like they're going to continue with the exercise because they're just trying to, even the situation that we're in today is, they didn't get to this engine bleed until today. So this is the first time they're going through it. They're going to go through all of these other exercises as they're talking about with the ICPS, which is the second stage of the rocket. So they're probably going to just carry through with this a little while longer, and we'll just have to see what, we'll see. Maybe they can come up with something else here, but it doesn't sound good for completing the test today. And so we'll stand by and see what see when the next update comes around.
Yeah. So you mentioned that this is the first time they've gotten this far, of course. They have already well beyond where they reached the last wet dress rehearsal attempt. In fact, you know this because NASASpaceflight never got to the point where we spooled up our live coverage because they never got close enough to terminal count for us to really begin our own coverage, because otherwise we'd be live for like 3 straight days. The question I have for you is, it sounds like they're going to, like you said, they're going to proceed despite that issue. Is this the reseating, the failure to troubleshoot this particular issue, going to prevent any other testing milestones from being completed, or can they get the vast majority, if not everything else, still accomplished, considering the core stage is fully fueled and everything like that?
I mean, my personal opinion is no, because they're not in a condition to actually start the clock again, and so that they would have to decide that this was good enough. I would say, considering the issues that they're still finding today, I don't know. Personally, I don't know that I would want to go into a first launch attempt for this rocket without having gotten farther than this. Again, just my personal opinion, but a significant number of the test objectives are still in front of them for this test. This period here from when they would pick up the clock. And so just to back up for a moment, remember we talked about that 168-minute long engine bleed conditioning. So if you're talking about an L- clock, we're probably significantly more than 10 minutes on an L- clock. So just to point that out. But then again, we'll wait and see what they decide to do. But what I meant was, they haven't finished filling the ICPS yet. They haven't got into stable replenish on the ICPS yet. So it would make sense for them to continue to stay in this configuration versus just stop and detank right now. But again, if I was betting on this, I would bet that we're going to stop before we start counting again and come back another day. But like I
Yeah.
said, I'm not in control. We'll have to see what they decide to do.
So just to recap, so the issue that they have failed to troubleshoot and will likely need to detank to do further troubleshooting won't prevent them from accomplishing a couple more objectives, namely finishing loading on the upper stage, but it would prevent them from releasing the T-10 hold and entering terminal count.
Yes, I believe so. So
Okay, gotcha.
just hopefully this it makes it a little bit clearer. Even if they had just fixed this and the valve was now reseating, they would still have, again, some large percentage of that 168-minute long chill down to perform. So
Right,
we
okay.
could still be looking at maybe a couple of hours of chill down to do sitting here with the clock stopped at 10 minutes. So, but they, since they didn't fix it, we're probably looking at, what else can we do in this configuration before we call it a day. I mean, I'm being pessimistic here, but this is not the kind of thing, generally speaking, that you would just continue with, especially if it's the core stage versus the second stage, the ICPS. So
Right.
I wouldn't expect them to continue unless they resolve this leak.
Right, gotcha. So we've got some questions coming in here, and so while we sit around and wait for another update as the teams look if they have any other options to troubleshoot that particular seal on the core stage, while also continuing to load the upper stage with liquid hydrogen, we're going to go ahead and dive into some more questions here. First one from Emmett, and this is a shuttle question, so I know Chris and Philip will be well inclined to answer. Will the SLS
Good.
make those barking/howling noises like shuttle did during fueling?
The what?
I think they might be talking about, wasn't there like an APU noise during the countdown?
Yes. Yeah. So right around in a shuttle count, right around 5 minutes, you would start the auxiliary power units, and you would hear like this chugging sound.
Yeah.
Basically, like the vehicle was coming alive, and then at around T-14 seconds, you would hear this sustained whine that would sort of start from the vehicles, and those were the booster hydraulic power units doing their things. And everything as well. SLS does have core stage auxiliary power units that will be started during the terminal count as well. I would not see any reason why you would not hear those. They're very similar to the ones that were used in the shuttle program in that regard, as they are not electric in any way, shape, or form like that. So I would expect SLS to make some similar noises in that regard to the hydraulic systems spooling up. Yeah.
We just have to hope that NASA lets the microphone audio into the feed.
Yes.
That would be something. Again, I don't know. Again, this is again, us evil media people have been complaining about the lack of commentary, and so we really appreciate that they are providing this commentary today. But it's still a restricted feed, so we would hear that chugging if we had a microphone up out at the launch pad for this test. The APUs will come up at T-4 minutes, and they'll be running that whole time. They didn't do it for Green Run. I don't believe we were able to hear that, but you've got the same. You need that same amount of hydraulic muscle to gimbal the engines, and then also for all the engine valve control stuff too. So I don't expect to hear it on this one, but it's not because it's not there.
Gotcha. Another question coming in here from Oliver, who asks, how much will SLS weigh once it is fully fueled? Do we have a complete wet mass for SLS?
Let me see if we can find.
Hang on, we can find that.
Yeah, I
Yeah.
was gonna say, is that something we have to search real quick?
Yeah.
Well,
Let's
we can
see.
talk about this a little bit while they look up the actual number. We'll get that for you, Oliver. Worth noting that the vehicle does get transported out with a fair amount of mass already on board because those two solid rocket boosters are fully casted with their solid propellants before they even arrive in Florida. The mass that changes during the actual countdown here is the core stage fuel, liquid hydrogen, liquid oxygen, which of course there is a lot of. I mean, look how big the stage is. And then also your ICPS up top gets fueled. Orion will already have its stored propellants on board and things like that. obviously during the countdowns during a crewed launch, humans will step aboard, but the mass of a human is pretty negligible in this sense. But it is actually fairly heavy before they even get into fueling ops. But once it is fully fueled, gentlemen, have we got a wet mass looked up?
It is, yes. It is an approximately 6.5 million pound rocket that will leave the pad.
There we go. 6.5 million pounds. Do we have a thrust figure for the 4 RS-25s and the 2 solids combined?
8.8 million pounds of thrust.
So 8.8 divided by 6.5 is a thrust to weight ratio of 1.35, and that's not small.
So actually, then the mass might be slightly less than that because its total thrust to weight ratio should be about 1.5. So I'm not far off on that. So it's about a 6.5 million pound vehicle, give or take the payload that's on board it, basically.
Gotcha. Okay, so
Yeah.
maybe closer to 6 million. A 1.5 thrust to weight ratio is pretty fast. Basically
It's
a
the
higher
space
thrust to weight
shuttle.
ratio is the quicker the vehicle will accelerate off of the pad. If you look at something like a Minotaur or something that's just a solid rocket motor, that's very high thrust and the rocket jumps off the pad, right? Throw back to that one Minotaur launch from Wallops that DOS freaked out about because of how fast it was. But SLS will actually jump off the pad pretty quickly, and that's because of those 2 giant solid rocket boosters that are attached.
Yes, indeed. Those things provide one heck of a punch when they ignite. Yeah.
Yes. Keeping the questions coming here, Outdoors Man asks, are 2 of the RS-25 engines from STS-135 and 1 of 2 were used on John Young's last flight? Do we have the RS-25 history in front of us, one of us, or do we have to look that up too? I know we have it somewhere.
We have it. Hang on. I
Okay.
know Daryl Nail went through this. One of the engines, yeah. I mean, the engines have a pretty big storied history to them. A few were used on STS-125. One was used on the last flight of the orbiter Endeavour, and everything like that. I am. Here it is. The history of the RS-25s that will launch Artemis 1. That's what I was looking for. Just give me a second to pull it up. Okie dokie. They have okay. So engine number 2040. So one engine is the biggest veteran with 12 flights to its name. Its first flight was STS-89 in January of 1998 aboard the shuttle Endeavour's mission to Mir.
Wow.
And the last flight of that engine was STS-135 with Atlantis on the final flight of the shuttle program, and also flew with John Glenn's flight in 95. Engine 256, which is engine number 2 on SLS, has 4 flights to its credit, including STS-114's return to flight after Columbia. Engine 258 is engine number 3. It has 6 flights, including STS-128, which took Christer Fuglesang, the first Swedish astronaut, into orbit. And then engine number 4 is engine 1060. It has 3 flights to its name, including the last shuttle flight on STS-135. All told, these engines have flown 21 successful shuttle flights over 3 decades of operations. So that's all 4 of them together have flown 21 missions over 3 decades.
There we go. And of course, that goes for the first couple Artemis missions. We'll use RS-25 engines that have been flight proven, if you will. And then they'll gradually phase in the new built engines once they have used up the flight inventory of engines that are to be reused on SLS.
Indeed, they do.
I'm going to keep some questions coming here. Again, if you have questions, please tag us with @NASASpaceflight in chat. I've got some more questions in the queue already, and we're going to keep going through these. I also want to acknowledge the people that are supporting the stream with their super chats, and some of these are questions as well. Justin Valenti, really quick with a super chat. Thank you so much for your support. 2 questions. 1, what are the 4 cylinders on the course section of stage 2? I'm going to have to figure out what exactly you might be looking at there. Also, the red pipe with what looks to be little. Oh, I know what the engine camera one is. Okay, if we get a cycle back, and this is for Patrick operating the stream.
Yeah,
If
the
you
red
get
pipe.
if they show the engine section view again, I want to jump to that because I know what he's talking about there.
Yeah, the red. Just so you know, since we've been looking at it all day, the red pipe is actually there's a whole bunch of different water systems that line the mobile launcher. So the red one is basically a fire extinguishing. It's called fire extinguishing system. So we don't want to see those pipes. We don't want to see water coming out of those, because that means the engines have shut down on the pad and they're cooling the engines down. The water deluge pipes are actually slightly out of the picture for the most part. I mean, there are some big pipes in the flame hole that the engines are hanging over, but hopefully we'll get that operational TV camera shot here again pretty soon. But yeah, there's you can see that red hose, and there's a bunch of water nozzles hanging off the end of it, and that's one of the Firex water lines. And they have those, they're all over the umbilical tower in case you were to get some sort of a hydrogen. The reason that they stop and are real careful if they see any indication of a hydrogen leak is because if that was to ignite, you can have a fire, which hydrogen burns clear. You can't really see it unless you're looking at a thermal image. And so they've got these water lines that they're gonna spray onto whatever they can to try and knock down a fire if they can.
Yeah, and to be clear about this, because I think a lot of people would probably be wondering, like, oh, but what's like, come on, like, when's the last time a hydrogen fire occurred, right? And the answer to that is it happened to Japan just a few years ago with their H-2B rocket when it was counting down and fueling for the launch of an HTV resupply spacecraft to the International Space Station. There was a hydrogen leak and a resulting fire on the launch pad. Thankfully, they saved it all and nothing bad happened, and the mission launched several weeks later. But yes, there was a hydrogen leak and fire on the pad at Tanegashima a few years ago. So even when you have a lot of experience with it, you stop and you take it very seriously because you have a lot of experience with it.
Yeah. Some more support that has come in here. Tommy Vasquez with some super chat support. Appreciate that as always. Neo, here's a great question. As for the crewed Artemis missions, will the crew have to board before propellant loading and wait for 6 hours? Where in the countdown do astronauts get aboard Orion?
Great question. So they will. This will go very much like the Space Shuttle and Atlas V, which we just saw for Starliner last month, in which SLS will be fueled prior to the crew going out to the launch pad. So part of this is so part of this, right, is that the countdown for Artemis 1 will be slightly different than the countdown for Artemis 2 because you will have to account for the crew needing to go out and get into the vehicle. Now, the way you normally do that is you put your full load of liquid hydrogen and liquid oxygen into both stages of the vehicle, in this case for SLS. And then a team will go out to assess the conditions of the vehicle as the crew then leaves the operations and checkout building and goes to the pad to get into Orion. That is usually timed for depending on how much hold time and wiggle room you want to build into your countdown, it can either be pretty quickly afterward or an hour or so after you enter stable replenish. But that's going to be the generalized timeline that they follow once crew are added to this equation for SLS.
Gotcha.
And that actually, hang on one more time. Sorry. That actually has to do with crew time on back limits. So there is a limit when you are in your pressure suits and you are in the vehicle for how long the human body can be on its back and waiting for a liftoff in that regard. And that is actually what drives some of the countdown requirements, not so much for SLS because it's got lunar launch windows that it has to meet. But if you go back into the shuttle program and you hear, oh, it's a mission launching a random science flight that doesn't have to hit a window or a specific orbital plane, we have a 2.5 hour window to launch. That's because of the crew time on back being in the orbiter. So that does become a limiting factor when the launch windows are long enough to potentially allow that consideration to come into play.
There we go. Thank you for the in-depth shuttle knowledge from both of you. I know that it's going to become very relevant in all of this SLS coverage, so we appreciate it as always.
We
I'm
haven't
gonna
held
keep
on to
some.
it for nothing.
Yeah, gonna keep some more questions coming here, and we've got one from Jonathan saying, after a successful wet dress rehearsal, what does the timeline look like for SLS? So we know they're still working on this wet dress attempt. It looks like there is potentially the chance that they will have to recycle and do it another time. Not sure they're going to complete everything this attempt, but we'll keep the updates coming. But once the wet dress hurdle is passed, whether that's today, whether that's a couple of days from now, whether it's in a couple months, whatever, what are the steps that go after that as far as launch readiness goes, Philip?
They will, and in fact, it was in the story that we talked about today. Of course, it was based on this going a little more smoothly than it has. But they'll basically prepare the vehicle to roll back to the VAB, and they'll roll back to the VAB and get it ready for launch. And there's probably about a month of work that's just that they know that they have to do. And the reason that they don't want to just say, well, we'll be ready to launch a month after wet dress is because they don't know what other things that they're going to have to do after this test. So again, we're seeing stuff like there's a few things like this hydrogen leak that they'll have to fix in order to finish the test, but they may find some other things. We were hearing that they had an issue with the crew access arm, for instance. This is what you would see for any crewed launch with Orion for SLS. You'd see the crew access arm would be up against the hatch all the way up until I believe 6 minutes before liftoff, and then they'd pull it back. But for this flight, because there's no crew on board, they had planned on retracting it back on either Friday or Saturday before the countdown started, but they weren't able to do that. And we heard from public affairs they just decided to leave the arm extended for this test. There's no issue with doing that, but they are going to have to retract it for launch, and they're also going to have to retract it just to roll back. So whatever issue they're having, they're going to have to address probably when they get back to the VIP. So that's one of those extra tasks that they already know that they're going to have to deal with. And we also just don't know what else we're going to see. Again, when they do this terminal count, they may be able to get all the way down to they may be able to get all the way through it, and they may find just some things that they want to tweak, and those could be software tweaks. But then even for that, you need to go and you need to do some testing to make sure that those changes are going to work well across the ground systems and then the vehicle systems as well. So there's about a month worth of just getting the system ready to go. Most of that would be in the VAB, and then there would be maybe a week and a half worth of time once they get back out on the pad to get ready. But they were talking about doing a little bit more of a faster pace to things. So if they had been able to get this test done today, they were talking about rolling back a week from today. We'll just have to see, because obviously they're still having issues with ground equipment here that they need to deal with. And so something like a hydrogen leak, unless they come up with some way to do this remotely, they're probably going to be out there for a little while trying to fix that and then get ready and get back into testing again and do this again. They had planned on just doing a practice scrub turnaround after this, but again, that was predicated on a relatively clean test, and so it isn't really going to make a lot of sense for them to just turn around and get ready. They were talking about potentially a 48-hour recycle test or a 72-hour recycle test, but you can't really do that if you need to take apart some mechanisms, look for a leak, maybe like tighten bolts like they did on the last on the previous leak, and then button it back up and get ready to tank again. So we'll just have to see. We'll have to see what happens here in the interim, because everybody wants to start talking about, okay, what's left for launch? Well, really, this is the big hurdle. They need to finish this test, and in a way, these little issues that they're having, I don't know, little issues, but imagine if these were launch attempts and we were getting ready to launch, and then they scrubbed and they had to roll back and come back out 2 months later to try another launch attempt again. So part of the reason that they did this in the first place is because they've never done it before, and the idea was let's go through this, screen all of the issues that we can get out of the system. It doesn't guarantee that they might not find something when they come to a real launch attempt, but the idea was let's test the whole system from end to end. And this is really focusing on the ground systems because Orion's been heavily tested up at Plumbrook. The core stage was Stennis in 2020 and 2021. And so this is really all getting the whole vehicle together, but also testing it with all the ground systems. And so they need, this is what the point of these tests was to make sure that the entire ground system and then the ground system connected to the rocket, that they all work together in this sort of choreography for a countdown. So we're still waiting. This is a big hurdle that they need to get over before they're ready to start really thinking heavily about launch.
All right, gotcha. We've got a bunch of questions coming in because we started talking about when crew onboarding or crew loading, whatever the right word is, crew ingress. Thank you, brain. Occurs during the countdown. We've got a bunch of other questions about how the crew will interface with the rocket during the countdown, things like that. So let's try and grab some of these. Let's see. First one, how will the astronauts get on the mobile launcher for boarding? I know that NASA awarded a contract recently for the vehicle that they'll ride out to the pad on. Once they get to the pad, how do you get up on the mobile launcher?
Yeah, so if you actually look at a photograph of Pad B without the SLS there, you can see that there are, despite the fact that we call it a clean pad, there are still interfaces that are there, right? There's the huge water systems, the propellant systems, all of those things. But there's also a little tower off on the west side of the pad deck. And
Which
that
is opposite the current camera view, right?
Which is opposite the current camera view, yes. Directly opposite it, so you can't see it from here. There's a little structure that has one elevator that brings you up to the mobile launcher levels. From there, they would have to get off that elevator, walk onto the deck of the mobile launcher, walk over to the actual mobile launcher tower, and then get on that elevator to go up to the crew access level. So very similar to how the Apollo crews used to do it with the Saturn V, where they had to transfer elevators as well. We got spoiled by that during the shuttle program, and then obviously ULA and SpaceX obviously just have the one single tower because of their pad systems and how they
Right.
work. So little different for SLS, but it's just you have to get on one elevator, get off on the mobile launcher zero deck, look at your rocket, and then get on the other
Yeah,
elevator.
it's all tied in with whether you brought your crew access tower with you or not, basically.
Basically, yes. Did you bring the crew access tower with you or not? I like that.
As if so, you need to first get on the tower that you brought with you, and then you can actually get on the tower itself.
That might be a merch idea, the NSF version of always check your staging. Did you bring the crew tower with you?
Bring your own crew tower. The other questions coming in here. Is the launch escape system the only way the crew can get off the pad quickly, or do they still have that bucket zipline thing?
So there is no zipline thing right now because there isn't a crew and on SLS, and they have not been sending out red team members to the pad to go up and down that tower during fueling. So for Artemis 1, we don't need it because we're not going to have anyone out there when the vehicle is fueled, which is when you would need that rapid escape system, basically from the pad. That is coming, and that will be added ahead of Artemis 2 so that the crew, if there were to be an RS-25 engine shutdown or some type of a hydrogen leak that necessitated the very quick evacuation of the launch pad while the crew access arm were still extended, that would be their escape route. At a certain point, the launch escape system is a launch abort system. Sorry, it's the launch abort system, LAS for Artemis. Although launch escape system and launch abort system are pretty much interchangeable, but it's called the launch abort system for SLS. So my apologies for mispronouncing or missaying that. But basically, right before the crew access arm is retracted, the LAS, the launch abort system, will be activated on Artemis 2 and beyond. It is inert for Artemis 1. And then if there were an emergency after that point, which necessitated a pad abort scenario, the engines would fire on the launch abort system tower and yank Orion and the crew away from SLS, and then pitch them out for a landing in the Atlantic. About 1.5 kilometers offshore is what they aim for here. Maybe a little bit farther with SLS. 1.5 kilometers is what they aim for Dragons and Starliners. So it might be a little bit further for SLS, given that it has a bigger
Test
boom
flight
radius.
of NASA's Orion spacecraft around the
Sounds like
moon
we're getting
and
an
back
update.
on the rocket that you see there on the pad, the Space Launch System. Okay, so it's official. The NASA test director told the ground launch sequencer to cancel the T0 time. So we are extending this hold. It's being extended while the hydrogen team continues to work a leak that popped up more than an hour ago. Let's update you on the 4 tanks, the 2 massive tanks inside the core stage and the 2 tanks in the upper stage. We are filling them with super chilled propellants, liquid oxygen and liquid hydrogen. Currently, core stage LOX is in stop flow, and that is planned because they're working a couple of tests, and they're going to reinitialize fill. The core stage liquid hydrogen is also in stop flow. That's because they're troubleshooting the hydrogen leak. The upper stage hydrogen is also in stop flow because of the same reason, troubleshooting. All right, well, correction. The LOX core stage is in replenish. It is the LOX upper stage, which is in a stop flow, that is doing a planned functional test of the vent relief valve. So again, go over them again. Core stage LOX tank is in replenish. Core stage hydrogen in stop flow while we troubleshoot. Upper stage hydrogen in stop flow for the same reason. Liquid oxygen in the upper stage in stop flow for a planned functional test. I want to talk a little bit about the issue that the team is trying to correct, and that is the hydrogen leak. If you look on your screen, we'll talk about exactly where this problem is. You look at the rocket, come down the rocket to the bottom of the rocket, and then look to the left. To the left of the rocket is the tail service mast umbilical, which contains a lot of flex hoses that you can see naturally droop in the middle as they connect to the bottom of the rocket. Well, those flex hoses, they carry propellants and gases in and out of the rocket. So the droop of the flex hoses, that's normal. When the rocket launches, those flex hoses, which are connected to the rocket by quick disconnect lines, they separate. One half stays with the rocket and the other with the flex hoses that are connected to the tail service mast. And so the issue is with the quick disconnect that is right at the base of the rocket, the liquid hydrogen bleed line, which carries the hydrogen off the rocket after it's circulated through the main propulsion system and the engines for pre-chill and kickstart bleed. It then goes back out and then out to a flare stack and is burned off. So it's that point that's connected right there at the bottom of the rocket. That's where they continue to work on coming up with ideas to fix a leaky seal in that quick disconnect line. They're talking about doing one more attempt. The first attempt to fix it did not work out. They warmed up the quick disconnect and then cooled it back down, hoping that the seal would reseat. It didn't work out. Now they're going to pressurize the area and hope that that kind of reseats the seal. And so that's where we're at right now. Again, no T0 at this moment. Stand by as we I'll listen to the teams continue to work this issue, and we'll have updates for you as soon as they are available. For now, this is Artemis Launch Control.
Okay, so to recap that update there, teams are still working to see if they've got any options regarding that seal on the core stage. They are going to extend the hold past the planned 30-minute hold, which is expected. This is not a scrub for the day, to be very clear. They mentioned that they canceled the old T0. That just means that original T0, which was like, I don't know, 4:38 or something, which obviously is only 2 minutes from now. Clearly that wasn't going to happen. That T0 has been ruled out officially, but they have not ruled out getting into terminal count if they can work around this issue and see if they can come up with a solution. Sounds like they're going to try and repressurize the area to make another attempt at reseating that seal. So the teams will keep working on that, and they'll keep giving us updates as they work through it. But right now, still at T-minus 10 minutes and holding to see if they can resolve that issue. Sounds like everything else that they have been working on earlier in the countdown has been resolved, though. They did also mention, what was the test they mentioned with ICPS? It looks like it was a planned test of a valve that required them stopping filling for a little bit.
It sounded to me like when they that this is in reaction to the issue that they saw earlier, and they're just taking time to do some troubleshooting, even though there isn't an issue to get more data. Because what they indicated when they were transitioning between hydrogen and oxygen on the upper stage, they noticed a surge in pressure in the oxygen lines, so they stopped. And if you remember, like they were talking about pressure a couple months ago in liquid oxygen lines and preventing anti-vortex protection there in regard to the core stage. And what they said in regard to the upper stage today for its liquid oxygen pressure surge is that the way they got around it, the way they fixed it, was to manually control some of the valves and manually move them into different configurations, which would alter the pressures in the core stage, but would not violate any of the pressure limits there on either end, either high or low. And now what they're saying is that they have voluntarily stopped liquid oxygen flow into the interim cryogenic propulsion stage and are doing troubleshooting on some of those valves. So it did not sound at all like there was an issue, just that they're trying to gain and gather more data on that system and how the valves are responding and operating and how the pressures are changing in the system, since they have the time to do so in this test.
Yeah, I was just listening. I just rolled the NASA stream back, and he was talking about they're doing a test. He specifically talked about a vent relief valve for the ICPS, and that's they're all the tanks have vent valves. Since you're constantly boiling off propellant, and you have to let that gas vent, and then up at the top, and you're putting more propellant in at the bottom. So they were planning on doing tests like this for both stages, and so I think they picked up the core stage test during the last tanking back in April, and they may have done some more of this, repeated that test today at some point. But this is the first time that they've loaded the ICPS, and so that does give them some confidence in that system. At least so far, it seems to be leak tight, and it seems to be functioning functioning nominally. So that's useful data, obviously, for the next time that they do this test. And hopefully, the one problem that we seem to have when we have a gaseous nitrogen issue is because it's at the very beginning of the day. We lost almost 2 hours again. This time that problem was not with Air Liquide or Liquid. I think the unfortunate thing is that we're all butchering their name. But they have two gaseous nitrogen supply legs. One of them also comes from a facility on the Space Center grounds called the Converter Compressor Facility, I think, the CCF. And they actually leaned on that in the test in April when they lost the the main flow from Air Liquide. And so, but today, before they could get started, they lost the backup flow from the converter compressor facility, and they won't start until they've got redundancy. So the problem is again, it takes a lot of time to kind of reconfigure the system, the purge. And so since we started almost 2 hours late, that's going to take, that's taking that time off the end of the window today for the launch team. And so at some point, the launch team's been here all day. So they were here at 6 a.m. Eastern when they had the pre-tanking meeting, or at least getting ready to go. And so they will probably knock off here at some point and hand off to another team. Maybe not quite yet, but it, especially if they're not ready to, if they're still dealing with this leak for a while, the end of their sort of work shift is going to come up here pretty soon. So I'm trying to think of that question that we were asked. So there you can see the FireX, that red FireX line, but I don't know what the other, because they were talking about cylinders.
Control
and the only
T-minus 10 minutes
in
holding.
Yep.
Want to recap again the status of the 4 propellant tanks on the rocket. The core stage liquid hydrogen tank and the upper stage liquid hydrogen tank are both in stop flow while the launch team troubleshoots a hydrogen leak. The core stage liquid oxygen tank is currently in replenish and stable state. The upper stage liquid oxygen tank is in stop flow for a planned test of the vent relief valve. Again, both sides of the hydrogen tanks, upper and lower, both in stop flow for troubleshooting a hydrogen leak. Core stage liquid oxygen is in replenish. Upper stage liquid oxygen is in stop flow for a test of the vent relief valve. And we're currently without a T0 time, as the launch director allows the liquid hydrogen team to continue to work troubleshooting. This is Artemis Launch Control.
There we go. So that's another update there, working on a hydrogen leak. It sounded like on the upper stage. Did I hear that? Did I copy that right?
No, I think we still have the core stage leak, but they've stopped flow for hydrogen to both stages because those propellant lines are interconnected. So
okay.
He's, I think, just trying to clarify what's going on with the vehicle. Although I think I'd say at this point, they're basically, they've got a list of test objectives for this test. There's the sort of a prime core set of test objectives that they will only get if they can pick up the clock at 10 minutes. Eventually they're going to do that, but they probably aren't going to be able to do that today.
Right.
But they're going to continue to tick off as many of the test objectives that they can, because it takes a lot of work to get into this configuration, just having the vehicle in relatively full and in stable replenish, or very close to it. So that's just, again, one of those things. So when you stop flow to the hydrogen tanks, they're continuing to boil off, and so even just to condition those tanks to get ready to pick up the clock again, there's an amount of time that you have to take to to top the tanks off, get back into stable replenish, and then sit there for a little while, because what's happening is when you let it just boil off, the hydrogen is warming up as slowly, since they're insulated tanks, but the hydrogen is warming up, and so the replenish also has the effect of bringing the bulk temperature of the hydrogen down, which is generally what you want. You want to condition the hydrogen so it's colder and more dense, also just, again, so you can run the engines for longer if you need to. So there are a bunch of different things going on here, and so really what they're doing at this point is they're just trying to achieve as many test objectives as they can, and then we'll see, again, if they're able to configure the tail service mast and this quick disconnect valve and say, okay, we can proceed with one terminal countdown attempt, I imagine that they would be willing to do that. At the outset today, they were talking about 2 terminal countdown runs, and even with the delays today, they were talking about a 2-hour test window for those runs between 4:40 p.m. Eastern and 6:48 p.m. Eastern, or thereabouts. So we still have, we're just about in that, at the beginning of that, hypothetical window right now. So in theory, they would still have time perhaps to make one run, and then you might start thinking about, okay, one of the media questions that came up in one of these teleconferences was, if you ever got into a situation where you could only do one run, would you consider doing that? And then basically saying, okay, we got enough test objectives so that we would take these other problems that we have and just take them back to the VAB and deal with those in the VAB and get the vehicle ready to launch at the same time. So, I'm sure they would be willing to at least have that conversation today if they could get into a position to do that. But, that remains to be seen.
Right, okay. All right, we've got a bunch of questions that have continued to come through here, so while we continue to provide updates, and also thank you to NASA and their commentaries for their updates as well that we are relaying, as long as those
Yes,
updates keep coming. Yeah.
yes, it has been wonderful to know what is happening with the vehicle on a regular basis. So kudos to NASA for the course correction on that.
Yeah.
Very much appreciated.
But I do also want to keep with the question answering, because that's what we like to do around here, and we can do that. And we were talking about some of the crew aspects earlier. We were also talking about the launch abort system. So really quick, some of these questions are pretty quick ones here. Does the launch abort system work even before first stage ignition? Basically, what's the earliest possible point where a pad abort would actually take place using the launch abort system? And then but then obviously in flight, but what's the earliest point that a pad abort could actually occur versus
I believe it. I
just
yeah, I believe
evacuate?
it is when. Yeah, I believe it is when you pull the crew access arm back, because other than
Okay.
that is in the way
Right, of
of
course.
a successful clean separation. So very much like SpaceX arms the launch abort system and then pulls the arm back, right? And they do that in rapid succession. There, it gets activated, and then your arm gets pulled back, but then the software logic goes, okay, the arm is back. Now, if I need to, I can fire it. But it's also worth noting that, like, the way this would work is like, okay, so you pull the access arm back, you've got an active launch abort system that can do a pad abort at that point with Orion. But that doesn't mean that if anything goes wrong with the rocket, even an engine ignition startup issue that results in the 4RS-25 shutting down on the pad, which in shuttle was called a redundant set launch sequencer abort, or RSLS abort. I'm uncertain if that's what they're still calling it in Artemis for the Artemis program, but you don't necessarily like ignite the launch abort system just because you have an engine failure, because pad aborts can happen in relative safety where your crew is fine, and then you can save the vehicle and they can just walk out across the crew access arm when the closeout crew comes to get them. So it's a little tricky answer and it's a little complicated, but it's basically crew access arm pullback is when you have that pad abort capability, but you don't always take it. It is still very dependent on what the issue with the rocket is after that point, as to whether or not the system would ignite to pull you away.
Yeah, I gotcha. Okay.
Right, and you would
Thank
get just a couple of notes. So I believe they're still baselining Artemis 2 launch operations, but I believe the crew access arm would retract at T-minus 6 minutes for Artemis 2. At least that was the baseline. So in that time frame, and just another thing to point out, obviously, you have automated logic to fire the abort tower under certain situations, but then obviously you have a crew on board who also has a it's probably a very similar thing to Apollo. It's like there's a handle that the commander is holding that to fire the launch abort system manually if he or she chooses to do that. But like Chris said, that's that's a decision you really don't want to make unless you are out of options. So, yeah.
Gotcha. Some more questions that have come through here. Here's a quick one. James asking, does SpaceX have to clear 39A for 39B wet dress operations? I believe, and Chris, correct me if I'm wrong, I believe the pad doesn't actually have to be clear, but I don't think they're
Correct.
permitted to do their own hazardous ops in parallel. Like a Falcon 9 couldn't be fueled at the same time.
That is correct, and that actually is not an issue between the two pads. Like, oh, like the pads are too close to one another, so the vehicles can't be fueled together. It's an emergency response issue for the Cape. And in terms of what emergency responders have to be planning for, because if you had an unfortunate situation where you had two rockets fueled at the same time and both of them encountered different issues that emergency teams had to respond to, you can't overstretch your emergency response teams. So a lot of this comes down to that. Now, there is also some things because Pad A and Pad B share nitrogen facilities, and nitrogen is needed for inerting the vehicles and keeping them safe. The SLS and the sheer amount of nitrogen that it uses does affect the nitrogen supply to 39A. So there is that consideration as well, that depending on what SpaceX would be trying to do there, they might not have the nitrogen supply to do it if SLS is doing something itself. But you are correct. The pads do not have to be evacuated for just a fueling attempt. I do, however, believe that 39A is within the blast radius if you intend to go skyward with SLS. And that would have an effect on Pad A operations, just because of the sheer blast area that SLS could have, right, as it goes up with those twin solid rocket boosters. But in terms of just fueling it, operations can continue at Pad A and vice versa.
Right. All right, keeping the questions coming here. We've also got some super chat questions here. Yoman asks, will SLS launch if the timer reaches 0? I know the answer to this is no, but it does prompt a more in-depth question. Basically, what's the difference when you program the rocket for a wet dress rehearsal versus an actual launch attempt? Like, is the programming actually the same and you just command an abort beforehand? Or do you program it differently so that obviously the rocket doesn't actually launch when it finishes its terminal count?
It's a great question. You basically remove the parts of the countdown sequence after the cutoff point. So you write a program that's similar, right? But of course, they've got test objectives they're not going to be doing during the actual launch campaign. So the software is
Mm-hmm.
slightly different, but not appreciably different, if that makes sense. It's not like we have to go test the software throughout the entirety of the system, right? It's not that type of a difference. And they've already done that, to be fair. But basically, you tell the count, okay, you tell the software, okay, we're going to cut off here, but the software doesn't have anything else beyond that. Like, it doesn't have software codes to ignite the engines. It doesn't have software codes to open the valves in the engines to start the flow of the propellants, which is why we cut off at T-minus 9.34 seconds, because it's very specific as to the cutoff point. And it's designed to cut off before you open the propellant valves into the RS-25s, where you would have to be concerned with drying them out in a scrub turnaround, which is going to take weeks. So basically, you just write it so that there's no possibility of going further than what you intend. And SpaceX does a very similar thing and uses a very similar system when they static fire the Falcon 9s, because obviously they are static firing past when the intended T0 time would be. So they just eliminate the part of the software that says release the vehicle from the launch pad, right? And that's a very similar thing with SLS. You just don't go past and you don't have software written that can actually ignite the engines and worse, ignite the solid rocket boosters. But none of the pyrotechnics have been installed in the booster rockets to ignite them, so we don't have that issue or anything. Well, I should say none of the pyrotechnics are connected in the way they need to be in the solid rocket boosters to actually ignite them today. So we cannot have an accidental ignition of the solids. And nor could we have an accidental ignition of the RS-25s. Yeah.
Right.
So that's a great question.
Right. We won't get so the specific answer is neither of those things are planned to happen, and really can't happen in this test. So we'll never get down to 0, and the vehicle's also not armed, figuratively armed, so that it could fly There's still some things that it needs to go back to the VAB. That's part of the work that they're going to be doing when they go back to the VAB to get it ready to fly, is to hook up, like Chris said, all of the systems that allow you to arm the vehicle to fire the boosters.
Right. And this actually ties into another question. Excuse me. Another question that has come through here asking, will they fire the engines? No, this is a wet dress rehearsal, not a static fire test. We know the core stage went through an engine firing test at Green Run and Stennis. There's not a planned static fire at the pad. The next time that those engines light will be for the actual launch. But that was a question from Space Nerd.
Yeah, and in fact, there is no plan to ever do a hot fire test on SLS ever again. That was only going to end up being for core stage 1. Even though the original plan was to send all the core stages to Stennis and hot fire them, that has been abandoned.
Right, yeah. Chat saying, the movie Space Camp lied to us? Yes, it did.
In many ways.
In many ways. Another question here. Vinshu, thank you for the Super Chat support. Does the SLS have an estimated launch date? Will SLS go back to the VAB after wet dress rehearsal? We touched on this earlier, so I'll recap. Yes, SLS is going back to the VAB for sure. It will hopefully only make one trip back to the VAB because it'll go back, get prepared for launch, and then go. Philip mentioned that the amount of work between a successful wet dress and a launch attempt is somewhere around a month or so. But it does depend on the data that they get back from the finished wet dress rehearsal, so it's a very rough timeline. So as far as an estimated launch date, a month or so after wet dress is finished, and then it will go back to the VAB. Ideally, it will only go back to the VAB once, but they could say, if they have to cut wet dress testing short and there's still test objectives to be completed, they could say, like they did last time, we're going to go back to the VAB to troubleshoot something, then bring it back out and do another wet dress attempt. But hopefully that's not the case, and we're not anywhere near there yet right now. Right now, they're just working a hydrogen leak issue that could result in a recycle after detanking, but not necessarily a rollback. So that's the current status.
And the only thing I'd add to that is that the current earlier than launch window target is the August one, the full August one that's in late August. They have ruled out the late July into early August window, which leaves us with just the mid to late August window at this point as the earliest possible.
Other support that's come through. We got a couple new memberships coming in here from Hazel, so thank you for your support there. Also, PBJ Spoon, thank you for the membership as well as Ben. All of you, thank you so much for the new memberships. Hope you enjoy the perks, and we appreciate the support. Some more questions that have come in here. AV99 asks, what are those black squares on the boosters? Those are optical markers for test objectives. Do we have some more detail into what exactly those will be used for?
They're used for. There are cameras. It's I don't know if we have the close-up engine shot, but you can actually see a couple of them on the core stage. You see in the middle, the core stage is in the middle of the picture in terms of the vehicle. You see the checkerboard in the middle of the core stage, and then to the left or the right, you see these white. They're cameras that are facing up the stack. There are cameras all over the core stage that will be streaming back to the ground when the vehicle's flying. And one of the major objectives that they want to get from a video standpoint is the dynamic motion of the boosters when they separate. They want to make sure that there's the amount of clearance that they're predicting aerodynamically up at that altitude. And so these checkerboards give them fixed reference points that they can use when they're looking at the video, assuming there's enough light if it's a lighted launch. But assuming that you have enough light to see the checkerboards on the core stage, they know where the cameras are relative to relative positions on the core stage. They know where the checkerboards are relative those positions on the boosters before they separate. And so then you can use those photogrammetry markings to map the motion of the boosters after separation. So you can barely see the aft booster attach points to the core stage. You can see the one we're actually looking at the backside of the vehicle, so the left-hand booster is actually on the right here. but they have those bolts will be blown by pyrotechnic devices, and then there are separation motors, which are also on. We can't see them here; they're on the opposite sides of the boosters. But those motors will fire immediately after the bolts are cut between the core stage and the boosters, and then the boosters basically just fall away from the vehicle, and the separation motors are going to try and push them away. And so this is the first time they're flying this vehicle. These are longer boosters than Shuttle. It's a longer sustainer stage and a different configuration than Shuttle. So they want to make sure that they have at least as much clearance, not just that you have a recontact, but that the boosters actually, that the separation dynamics are more or less as they predict them in aerodynamic models. And so this will basically give them, you can't call it ground truth, but this will give them flight data that they can compare to their aerodynamic models.
Flight truth,
Right. But yeah, and you can see below the boosters here, you can see checkerboards on the hold down posts. And so they're going to do some similar, and you can actually see it down here under the red Firex. You can see one on, that's an engineering camera. They have film cameras, high-speed film cameras and high-speed video cameras. They'll be using those photogrammetry markings.
T-minus 10 minutes and
also to map out the
Space Center in
motion.
Florida for the Artemis 1 wet dress rehearsal. Got an update here from the launch team. The liquid hydrogen team is done troubleshooting this hydrogen leak in the quick disconnect line between the rocket and the tail service mast. It's a leaky seal on the rocket side. And so now they're working on some proposals. One recommendation they have, and this is just a recommendation at this point, is to see if they can get as far as possible into terminal count. And the way they want to do that is they want to put the hydrogen core stage back into replenish. It's actually down to 94% right now because of boil off after they hit stop flow during the troubleshooting. And so they want to put that into replenish to bring it back up to the flight level in time for terminal count. And they've been talking strategy and running scenarios in Firing Room 3 to see what they need to do to get through terminal count. And one of the ideas, and I want to emphasize these are ideas and proposals at this point, is to make an adjustment to where the launch computer doesn't see the hydrogen leak and then start terminal count. And then what's being proposed and what's being discussed, try to get down into around the T-minus 1 minute 30 mark. But again, the hydrogen team still working on this proposal. They went to the launch director, Charlie Blackwell Thompson, to get permission to go and work that, and she did approve. So that's what they're looking at now. They've got to bring it back. They've got to refine it, continue to work it, and bring it back to her. And so that's what we're waiting on right now. We don't have a T0 as a result of that. And so the team is standing by. At this point, if this were a launch, this would be a time for the team to work, but we're all obviously extended through the original 30-minute window. And because this isn't a launch, right, because we don't have to rendezvous with the moon, the launch director is allowing her team to work. So we'll see what the team comes up with, and we'll keep you updated. This is Artemis Launch Control.
Okay, so that latest update ties right into a question we had earlier where we were talking about could this hydrogen leak be worked around and still get further into testing. It sounds like the teams are, and again, he emphasized many times that this was a proposal, but it sounds like it is possible that they may be able to adjust their terminal count procedures to get a few more test objectives done despite that persisting hydrogen leak, which would be good because then you would no longer have to do a full detank, get out there, fix the hydrogen leak before reaching those test objectives. The more objectives, obviously, you can check off at a given test, the better. So sounds like that is a potential path forward, but they are still working on finalizing that plan and whether it's feasible. So we'll have to stay tuned to see if they actually choose to go down that path.
Yeah,
It
this
also
is
would
interesting.
indicate that the leak is not big.
Right.
Whatever it is not big, because they would, if this were a significant leak, this would not be. They would not be saying, "Yeah, just let it keep leaking and let's fake out the
Right.
computer so
Yeah.
it doesn't see it and just go for it." Like they wouldn't be saying that if it were significant. So that does shed some light on potentially like it's leaking, but it's leaking at such a low amount that it's like barely violating your part per million count limits or something like that. And maybe since we're not igniting engines today and we don't have a potential flash source, we're okay to keep going. But I want to stress a couple of things that you heard in there. The team came to Charlie with the proposal, and Charlie didn't say, "Yeah, that's good." Charlie went, "Yeah, go back and keep working on that plan and
Mhm.
come back to me."
Right.
So she did not outright approve it, which is
Right.
also very, very important to note.
Well,
But
and
that is
they have
interesting.
the
Yes.
they have the full. This is this is the entire management team is here. So they're this is sort of practice like you fly. So the mission management team has they gave the go to begin tanking at the beginning of the day. So they're still there, and they will. These are the right people. They have everybody they need to talk to about this. So a couple of things. I don't think we mentioned this in the broadcast itself, but they actually did change. So he mentioned Daryl Nail, the NASA commentator, public affairs officer, mentioned that this was the flight side quick disconnect, and this is a system that was changed after the green run. They actually replaced the line and made it replaced it with a line that has a slightly larger diameter. And so this actually was not hardware that was run at Green Run. So it's possible maybe that we're seeing something here. Again, this is behavior. This is new behavior on the flight side. But then stepping back, big picture, I think, I guess the theory is, or the strategy is probably a better way of putting it, is they know the engines have a lot of flight experience. They're not flying today. They're not going to, as we've been talking about, they are not going to fire the engines. They don't. The engine bleed is only, I don't want to use the word necessary, but they don't necessarily need to. I used it anyway. They don't necessarily need the engines to be in the start box today, because they're not going to fire them. This test is primarily to test the ground systems, that the ground systems can fuel the rocket, that the ground systems can sequence the countdown all the way down, to those cutoff points that we're talking about. And, listening to the way that they're talking about this, if they did approve this plan, I really think, and then actually be able to pull it off, which is another question. I would not be surprised if they have the discussion of, is this good enough to call, to does this satisfy enough of our test objectives for this test, to, like we were talking about, just say, okay, we'll roll it back to the VAB, we'll fix this bleed valve on the core stage in the VAB, and then we'll come back out for launch when we're ready to do that with all of the other, they'll find other issues here in this countdown. But what's interesting to me is it sounds like they're talking about a possible path to finish this test today. They may not actually be able to pull it off, but that's what it sounds like they're talking about to me. And like Chris said, they may go to the mission management team with this proposal, but that doesn't mean that the mission management team is going to approve it.
Right. And Philip, there was one other thing I caught, and I'm wondering if this is a change or if I'm just or where, when they do the initial run into the count, Daryl from NASA Public Affairs just said count to 90 seconds. He said count down to 1:30. My memory of that was that the first run through Green Run was going to go down to 33 seconds, hold at that handoff point, and then cut off there, recycle, and then they would come back and do the run down to like 9.34, and that first run to 33 seconds would involve a terminal count hold, like after you pick up the count at 10, hold for like 3 minutes at 4-minute mark, and then count down to 33, hold, cut off, recycle to demonstrate that, then come back. Do I have that right, or was the plan to always just go down to 90 seconds for the first run? Because if not, that timing has changed.
No, you had it right. They were gonna, for the first run, they have this 3-minute hold. The test objective, which was to accumulate 3 minutes of hold time somewhere up to the 90-second point, and then pick up, run down to 33, hold, cut off. So you had that right. I think the issue perhaps is, again, I'm thinking of shuttle days, but the engine ready indications, I believe, are inside that 90-second point. And so, again, given the time constraints, and given that they, if they're not going to do the engine bleed and the full engine chill down, it's possible that might be as far down as they can get. But that would exercise the ground side of the terminal countdown sequence all the way up to that hold point, and that hold point is where they would transition from ground power to vehicle internal power on the core stage. But again, like I said, I don't know if this sounds pretty ambitious to me, this plan. Pardon me, but this would take them. They would be able to verify that the ground system can pressurize all of the propellant tanks from the core stage and the ICP. I believe the ICPS. It's possible not, but I do think that the ICPS is a much smaller rocket stage, and I don't think they're really worried about. I think they're worried about getting a sequencing on the core stage. So we go through those again. You have pressurizing the core stage tanks, which starts inside 6 minutes. Then you have the core stage APUs that we were talking about earlier. That is a ground-based helium spin start system. They start energizing that at 5 minutes, and then they spin the core stage APUs up on helium beginning at 4 minutes. They'll do the engine thrust vector control. They do a canned gimbal profile. They would do that test at 2 minutes 30 seconds. And so what they would not get is they would not get the handoff from the ground sequencer to the core stage flight computers. They wouldn't get the autonomous launch sequence, which begins at 30 seconds. And so, again, the core stage at Stennis did not have the boosters attached to it. They did not have the ICPS attached to it, but they have exercised that software to a great degree in past tests. And so I could see them. I can see the strategy here, but again, it is absolutely worth cautioning. It's just a proposal. It doesn't necessarily mean that they're going to do this, but I don't know if they have to scrub, turn around, and come back again and do another test. I don't know how much value there is in getting one terminal countdown run in, because again, if they find issues in that before they get down to 90, or they pick up a bunch of issues when they going down to 90, you would think, well, what do are you gonna fix just those and not fix the hydrogen leak? So anyway, it'll be interesting to see if they do decide to go ahead and proceed with this sort of an abbreviated test. And if they do that and they're able to get all the way down to 90 seconds, whether they would consider that to satisfy enough test objectives to say, okay, we have enough information to say that the next time we feel this vehicle would be for launch. That's pretty ambitious.
Right.
But it sounds like they're talking about something like that, or at least the steps on that path.
So yeah, we'll keep an eye on what the decision actually gets made, and of course, this all, even no matter what path they take today, what really matters is what the data analysis afterwards looks like, however many objectives they were able to check off, and then what's left to prove before being able to, declare the rocket launch ready. Um,
And a thing that we haven't really touched on that's really quick is just because, like, let's say this works, right? Let's say this plan today works, right? And they do get to 90 seconds and they get all that. That does not preclude them from saying, great, we learned a lot. We're going to try it again in 3 days. I mean, that
right, yeah.
nothing precludes them from coming in and saying, that was good. We want to do it again.
Yeah, the getting down
Right.
to 90 seconds or so today is definitely preferred to stopping short and having to call it here, even if it still means you come back for yet another wet dress in a few days because you were going to go fix that hydrogen leak seal, any other issues that you learn of during the terminal count, and then you can get one more countdown through that maybe it goes through even smoother, and that gives you that much more confidence going into the launch attempt.
That's a
Then,
good point. That's a good
yeah,
point. And as an example, this issue, this hydrogen leak that we're seeing, it's possible that that's been there for a while, and it's only because we got to this point today that we were able that they were able to uncover it, so to speak. And so, like you said, there's some value in continuing down as far as you can. They may find they may, if the sooner that they find that they learn some of these issues, the better. It just gives them more data, like you said, that they can consider in terms of where do we go next from here.
right. We're going to keep some questions coming here. We've got a whole queue of questions still, so we're going to keep those coming. I've also got some super chats that I've been sitting on here. I want to get through these as well. There's a rapid fire thank you for all the support, Ramesh, asking, do you still think they have to go into the VAB? Well, we know they have to go to the VAB at least once because the final launch preparations require a rollback and rollout, but we are hoping that it is only one trip to the VAB and not a trip to correct wet dress issues, roll back out for another wet dress, and then roll back for the launch preps. That's very much to be determined, but hopefully only one trip to the VAB in the future for this particular rocket. Thanks for the support. Our very own Patrick wants to know, what are the 4 tanks for? Those are for holding the propellants, like we've been talking about today, and they differ from the 4 towers, even though there's only 3 towers, unless you count the ML. I guess that's a 4th tower. But thank you, Patrick, for your support. Rough Riders Show with a question. If this was a launch attempt, it would already be a scrub, right? Given that they only have a 2-hour launch window each attempt. No. So the simulated launch window for today, I think you said opened at right around 4:40, right, Philip?
Well, he's probably right, because remember, they were supposed to, the original window was 2:40 to 4:40 p.m.
Oh, that's right. Yeah.
So yeah, we would. Yes, it's very likely we'd have already scrubbed, and in fact, it's possible we might not have even tanked the vehicle given that delay at the beginning because it was so long. They may have just said, let's come back tomorrow, because now they won't be able to come back tomorrow. I think realistically, the minimum would be a 48-hour recycle, and I think realistically we're probably looking at a little longer than that.
72 to 96 is probably better on the
Right.
lower end of that projection scale here. Yeah.
Right.
And also worth mentioning, the question mentions a 2-hour launch window each attempt. I believe the length of each launch window does actually vary from day to day. It's
right.
not always
2 hours.
2 hours.
Yeah,
Yes,
2
it
hours is
does.
a maximum. 2 hours is a maximum launch window for this mission. Maybe someday they'll have longer windows that they can sort of be more flexible about, like SpaceX is with the Falcon 9, where they look at the weather coming in the afternoon and they're like, let's try the back end of the window instead of the front.
Yeah.
So
the tricky part with SLS with that, because they can totally do that. The tricky part with SLS though is the sheer amount of time before liftoff that you have to start fueling it. And yeah, you can get into some questions about, like, you could delay fueling for 2 hours if you have a 2-hour launch window and still make the end if you encounter no other issues. within that, but it becomes trickier just because of the way the systems are fueled, right? To make those sort of long lead adjustments versus, okay, we fueled and we're in the count and now we just have to hold for 2 hours to wait out the weather. But I will note too that maybe it's possible in the future to eke out 30 more minutes of a launch window based on vehicle performance or things like that. But
Pardon me.
crew time on back is going to start to become a a mitigating factor in how long an SLS launch window can go if you have
Mhm.
a powerful enough rocket that can account for the plane change maneuvers that you would need to do launching slightly off plane.
Right. Right.
Gotcha.
But I mean, it's the 2 hours. I'm sorry. I don't want to prolong this too much longer. But
No, you're good.
the maximum 2 hour window is really just it's because this is the very first launch of the vehicle.
Right.
They're trying not to overly complicate an overly complicated situation.
I'd seem to remember there actually being a NASA spaceflight article once upon a time about the launch constraints for Artemis 1 and how they are expected to change after the first flight. So,
Right.
somewhere, maybe if I can look that up. Hold on. I have the internet at my fingertips, and all of NSF articles also within pretty easy range here. I bet I can find that.
Yeah, I was going to say some of the constraints just outright go away, and then some of them get modified, elongated, altered to where they're kind of like, well, it is a constraint, but it's not a constraint because it'll never like there's a wind constraint for how long the vehicle can be out at the launch pad based on the wind loads that go through it. And they've talked about, oh, like we're monitoring that for SLS and Artemis 1, but we're not close to it just yet. They can stay at the pad as long as they want. That functionally becomes a constraint they will never run into, right, for Artemis 2 and beyond, because these things will not be at the pad as long as Artemis 1 is at the pad.
Let's see. Inside Artemis 1's complex launch windows and constraints. That's the one I'm looking for. By our own Philip Sloss. Let's see. I'm gonna throw this into chat here. I gotta actually pull up the YouTube chat because I'm not usually looking at the YouTube chat, but I can put it right there.
Yeah.
So, folks, if you would like to read up all the details behind the Artemis 1 launch windows, there you go. I'll put it in there a couple times. And by our own Philip Sloss, of course. So there you go. Anyway, back to some more questions. And it's pinned in chat now. Thank you, Chris. Other Chris. We have multiple Chris's around here, in case you haven't caught on to that yet. I'll keep the questions coming, though. Because this view is up. Justin, you asked earlier and you're asking again, and now I know what you're talking about. In the pad view, what the 4 cylinders are facing out of the engine section at an angle on the core stage engines. So if you look at the view we're looking at right now, just above each of the engines, you see these 2 kind of small cylinders that are facing upwards and slightly at an angle. I think that's what Justin is asking about. Do we have any idea what those are?
Yeah, those are the cameras that I
Yes.
was talking about. So yeah, if we're talking about on the core stage, yeah, those are forward facing cameras, and there are cameras on there would be cameras on the opposite side of the vehicle down here, but they're also going to be up at the top of the core stage as well. So and in fact, these photogrammetry markings that we've been talking about, there is a significantly larger number of those markings on the other side of the vehicle, which is ironically the side of the vehicle that you can see decently well from where Chris is right now. So this is this camera that we are getting the view from is on the launch umbilical tower for the mobile launcher, and so we're looking kind of at the generally would call the backside of the vehicle. But I don't know if now he's talking about 4. I only see I'm only seeing 2
I only
here.
see 2.
So I don't know what other. So now if we're talking about stuff around the around the base of the solid rocket boosters, there's a bunch of stuff. You've got those 2. We can see 4 hold down posts. Those have the checkerboards on them, the gray hold down posts, and then the white the hardware that's covered in that has sort of the white tarps over them. Those are aft skirt umbilicals. There are 2. There's the aft skirt electrical umbilical and the aft skirt purge umbilical, and it's sort of a combo umbilical connection, but they obviously have they've covered those to keep rain out of them. So
And the
and
only
then
other thing I can think of, did he specifically mention the color?
No, they did not.
The only other thing I can think of, because there are 4 things, I mean, the only other thing I can think of is if you're talking about the gray things that sort of go up toward the solid rocket boosters, those are just their hold downs. That's just literally where the vehicle rests. And they're not even hold downs. They're just literally the resting points where the boosters connect with
right.
the pad.
Also, just a really quick, we got a super chat here saying #PhilipFanClub, and I would like to strongly endorse that. Thank you, Philip, for all of your knowledge about SLS. You can point to a random umbilical and know exactly what it is, so appreciate it.
Yeah, you better really like shuttle and SLS to go on a road trip with Philip and I.
I've got some more questions in the queue here, and Austin asking, what's the status of the Artemis 2 vehicle? Are they waiting for certain assembly steps while Artemis 1 is still in testing, or is that continuing? What's the status of the next SLS rocket?
Yeah, I can take this from a couple of different perspectives, and then I'll pass it over to Philip for additional stuff. And I am not the person to talk about the core stage. That is Philip. The Orion for Artemis 2 was successfully powered up for the very first time. The last week in May, we talked with Lockheed Martin. In fact, there is an article on our site right now which details not just the Orion for Artemis 2, but 3, 4, 5, and 6 as well before they start reusing them. So I highly recommend you go check out Lockheed Martin and Orion. And if we could pin that in chat, that would be awesome as well, because that does give a great overview of where all the Orions are. So basically, Orion has been powered up. It's got a lot of outfitting, a lot of internal and external work that still needs to be done. It is basically just a pressure shell with some added stuff onto it at this point. But a lot still to go on that one. The European service module for that mission is here and undergoing some of its post-Florida delivery checkouts after it arrived from Bremen, Germany, and the European Space Agency. So it is here for Artemis 2. The ICPS is complete for Artemis 2 and is in storage. The solid rocket boosters for Artemis 2 are complete and are in storage. The RS-25s are obviously shuttle heritage leftover hardware, so they are just ready to be they are getting ready to be installed onto the core stage for Artemis 2. So things are definitely progressing well on that front. There are some things from the Artemis 1 Orion once it comes back that they will pull out of it. Some electronics assembly boxes and avionics boxes and seats for the crew will be taken off and reused on Artemis for the Orion for Artemis 2. But right now the Artemis for Orion. The Orion for Artemis 2 is slated for handover delivery to NASA in Q4 of 2023. The core stage is in production at the Michoud Assembly Facility, and this is where I will pass it over to Philip.
Right, and I think I know we're expecting an update from Public Affairs here at the top, and we're at the bottom of the hour, so they may cut me off, but we do want to make sure that we stay up to speed on that. The core stage 2 is basically in 2 pieces now. So the upper 4/5 of the rocket, so the forward skirt, liquid oxygen tank, inner tank, and liquid hydrogen tank are all connected up together, and they're finishing up the engine section. They just recently moved that over to final assembly to finish integration testing, and it is to be mated to the rest of the vehicle in the fall. And then, like Chris was talking about with the engines, once they do that, we should see the engines being installed within a couple of months after that. So we should probably be looking for that to be completed here probably in the next year or so. It'll obviously they'll obviously adjust that based on when they need it. I think right now Orion would be critical path for Artemis 2, because as Chris said, the Orion crew module has to wait for this Orion, the Orion for Artemis 1 to go to the moon and back. And so even after they launch, Artemis 1 could be as much as a 6-week long mission. So it could be a while before, it'll be a while for to complete it. So yeah, we're actually talking with NASA about getting a little bit more of a detailed update on production at Michoud here, hopefully in the next few months.
All right, thank you. And really quick, I know we're expecting a PAO update soon, so knowing my luck will get cut off here. But really quick, actually, a question in our back channel from Chris that I'm just going to relay to Philip right now. Are there wet dress rehearsals planned for Artemis 2 and beyond, or is this only an Artemis 1 thing?
No, they're
actually,
quite a bit. They're because they're going to be changing configurations, or there are just major changes. So Artemis 2 is the first crewed mission, so they're going to they're going to do a tanking test of that vehicle. I don't think obviously I don't think there's any reason to do a fuel test with the crew on board. They don't do that anymore. In fact, I don't think they did that with even back in the Saturn Apollo days. They used to do what they call the wet countdown demonstration test, but that was actually they would actually do a test without fuel with the crew on board, and then they'd recycle and then do a fueled test without the crew. So, but they are planning on doing some kind of tanking test for Artemis 2. Maybe they don't do one for Artemis 3 because you're kind of in more of a stable configuration, but then that's the last one of the Block 1 vehicles. And then the Block 1B vehicle would be coming with Artemis 4, and that's essentially not a brand new vehicle, but it's a significantly different vehicle, and they will treat it like a first flight. So yeah, they'll probably have a full wet dress rehearsal for that one, just like they're doing with this one.
All right, gotcha. Thanks. Let's see here. Another question here. This is a good one, Taylor. What is the difference between a wet dress and a cryoproof like we see at Starbase? Why the different terminology? So the big difference there is what you're actually putting into the rocket. A cryogenic proof test that we see get done many times in Starbase, for example, is using some generic cryogenic fluid, whether it's liquid nitrogen is the most commonly used. It gets you down to the right temperatures that the rocket will experience on a flight day. However, you're not using the actual propellants. For example, in Starbase, you wouldn't be using liquid methane and liquid oxygen. A wet dress rehearsal uses the actual propellants that will be used. So, in this case, SLS, they are loading it with liquid hydrogen and liquid oxygen, not just some other cryogenic fluid that's inert, because on a cryogenic proof test, the reason they use nitrogen is so that there's no accidental risk of ignition. And then later on, they get into wet dress rehearsals and static fire attempts and things like that, which obviously you need the real propellants. But that's the difference between those two different kinds of tests. Were there any sort of cryoproof testing prior to this with regards to SLS hardware?
They didn't do. Well, I guess there's a couple of different ways to answer that. Because this is a first flight development campaign, they did do a test. They did tests on a structural qualification article where they essentially they didn't completely load it with cryo with liquid nitrogen, but they loaded the tanks up to like the first weld line with liquid nitrogen, and then they pressurized it up to. They basically they did a whole bunch of tests to the standard the standard limit load and ultimate load. Limit load being basically 100% of the structural loads you expect to see on the vehicle, and then margin. So an ultimate load would be 140% of the loads. But then they basically did a test of failure for the two propellant tanks for core stage. The liquid hydrogen tank article that they used, they actually didn't use liquid nitrogen in that test because they knew that there was a decent chance the tank was going to actually physically fail, and it did. But they pressurized the tank, and then they put 206. They got all the way up to 260% of what they would see, what they would consider to be maximum flight loads before it just basically unzipped. And so there are different types of proof tests. So they're doing, we're also talking about different types of materials for the core stages, primarily an aluminum, an aluminum alloy. The SpaceX, the Starship is using more of a stainless steel, primarily stainless steel material, and so the proof tests are different for flight articles. So they don't do a combination like SpaceX does, where they fully load the tanks and then do, again, and I don't know, I'm not sure if we know what whether they go up to ultimate load, for instance, on the Starship tanks when they're doing those proof tests, because you want to be careful with, you don't necessarily want to overload the system when you're going to fly it. So it isn't exactly the same, but they do proof test all the flight articles. It's just that they're, for the flight articles, they do a hydrostatic test on the liquid oxygen tank, and which is basically they fill it with water, which has got the same kind of density as liquid oxygen. And then for the hydrogen tanks, it's a pneumatic test where they put different types of, they hook up a hydraulic system to the flanges, and they pressurize the tank to a nominal pressure, and then they put loads on it to make sure. And again, the point of the test is to verify that your welds are good. And so obviously you don't want to necessarily test those to failure because they're flight articles.
Right. Really quick, I want to jump in because the engineering cameras are being tilted,
Yeah.
I believe is the correct term. Jack Byer will let me know if I got it wrong. But looking around the core stage, looks like they're inspecting some of those umbilical lines. Those are kind of raceway lines. What I don't know what the exact wording for those particular lines are, but looking up the side of the core stage, looking upward before they come back down to the engine section now.
Yeah, those are some of the pressurization lines that run up both sides of the tank.
Right. You have yes.
On the
So
right, and then on the center,
right.
you have the liquid oxygen feed line that comes down from the liquid oxygen tank. And this is identical on both sides.
Mhm.
And then you have the cable tray race
This is
array
Artemis
on the
launch
left.
control at T-minus
NASA.
10 minutes and holding. So the team on the hydrogen side has been continuing to work a proposal to continue terminal count, even though they have a leak on the liquid hydrogen bleed line. This leak, stand by.
He's listening to the launch team talk right now, which is why.
Right, yeah, he's probably listening in, and he'll give us another update. But we'll just jump in. We are getting an official update on the status of the countdown now from Daryl, so we'll keep listening for him to come back here.
What
It's
was
been a
the
long
question
day
you were
for him too.
answering? Yeah.
The just to note,
yeah.
we're looking at the pan. So the systems tunnel, which is on the left, that
sorry
is
about
only
that. I
on
was
one
catching
side
an
of the
update
rocket.
on the
NASA.
upper stage liquid oxygen, which is currently in topping and is just a few minutes away from going into replenish. All right, so quick update on all the tanks. Core stage liquid hydrogen, upper stage liquid hydrogen, core stage liquid oxygen, all three in replenish. Upper stage liquid oxygen just a few minutes away from being in replenish. Okay, back to the proposal for the liquid hydrogen leak. The team is proposing to see how far they can get in terminal count, and the goal is to get to a moment where the ground launch sequencer hands over control to the autonomous launch sequencer, which is on board the rocket. Ground launch sequencer is the computer here on the ground, here at the Launch Control Center. But then at a moment a call at T minus 33 seconds is given to transfer that to the autonomous launch sequencer. They're aiming for that moment to learn as much as they can about terminal count, starting at T minus 10 minutes and getting down to T minus 33 seconds. So the proposal includes masking some of the warnings that would come out from the ground launch sequencer. It would be throwing some warnings if they conduct a terminal count while the hydrogen bleed is still active. It would stay active because there's a leak and they don't want to pressurize it, could make the leak worse. So the rationale behind keeping the bleed but then masking that from the launch sequencer is that this is part of normal safing of the vehicle, is to establish a bleed. So the engineers, a lot of the top minds in this room that have been discussing this are comfortable with that rationale. With the strategy being the further you go, the more risk you are buying down. So there is the possibility of another WDR out there. One of the things that was also discussed is that the team can get access to that tail service mast out at the pad. So if they need to, they can go out there and take a look at that leak and work that. Standby.
Well, while he tells us to stand by, just a quick recap so far. It sounds like they are really seriously looking at that plan to go into terminal count here. Although also emphasizing that that would not necessarily rule out coming back for another wet dress rehearsal, but the further you get down, the more risk you buy down, which basically means the more data you collect, the closer you are to launch readiness after today's test, even if you still need to do another one afterwards.
And Philip, correct me if I'm wrong. Do we know if this is if the leak is on the vehicle side or the LH2 umbilical arm side? It sounds like it's on the umbilical arm and not the vehicle.
Well, he did say it was on the flight side quick disconnect. Again, we'll obviously have to get a little bit of clarification when the next media
Standby,
telecon
the
we
launch
do.
director is asking about how much longer it may take to develop this plan and put it into work. Standby.
Yeah, the only reason I asked the question of where it is in flight side quick disconnect, I guess you could technically say that's the vehicle,
NASA.
but it's not a system.
Okay, don't quite have an estimate on the time yet. So that is currently the thinking by the liquid hydrogen team, is to see, and by the SLS chief engineer, they're discussing getting further into this terminal count and the value of that. Charlie Blackwell Thompson, as I just mentioned, was asking the team how they're doing. It's worth noting many of them were in at 5:30 a.m. Eastern time, and so they are going on 12 hours. And so she's taking the pulse of the team, getting some of their thoughts on this, and then also trying to find out how much longer it would take to develop this plan. So we are still standing by as the team continues to develop this plan. Again, on the tanks, we are now in replenish for all 4 tanks. We've got a fully tanked Artemis 1 rocket that you see right there, sitting on Launch Complex 39B. This is Artemis Launch Control.
Okay,
Right, so
that's
they're
interesting.
basically
and
just
kind
still
of-
working on the plan.
But then
Yeah,
now
but
they're talking about
the
going
lab-
all the way down to 33, though. That's
Mhm.
interesting.
Yeah, also hang on. Did I miss something in a previous update? Liquid hydrogen flow to the vehicles had been stopped. So how can and then the last update Daryl said was that the liquid hydrogen tank was at 94% and teams want to get into a position to pump more in because stuff has boiled off, but then Daryl just said it's a fully fueled vehicle, which is not correct if hydrogen is not flowing to both. system.
At the beginning of this update, it sounds like they had gotten back into stable replenish on the hydrogen lines.
On all of them. Okay.
Right.
Yeah.
They basically, so you had, if you're at 94%, you don't really have to reestablish fast fill, but you have to get back up to the, you just basically have to get back into topping and then stable replenish. And so, I think he may not have explicitly said it, but I think when he was talking about that, he was talking about how they obviously need to get back into that configuration to start the terminal count. But we're still, the other interesting thing is that, I'm going to be kind of curious to see whether we'll probably have to ask them after the fact if they actually do this terminal countdown run, whether they're able to terminate, replenish, and pressurize the liquid hydrogen tank with the bleed valve open. So I have a feeling, again, it is basically what it comes down to is they're trying to buy down risk. And the question is, how much can they buy down today, and how, what the value of that is. And so that's, I think, that is kind of the discussion. It does sound like there is some value to them, though, which I think is interesting because, if you guys remember, I was pretty dismissive of it, and so I'm a little surprised that they want to continue to do this, but it is, they would obviously know better than I would.
Yeah, the other interesting thing to keep an eye on here, which is in all likelihood the thing that will actually end up getting them today, is not the team putting together the plan for how to proceed and management going, no, we don't want to. It's probably going to end up coming down to how long the crew has been on console, as Daryl noted there.
Right.
The team doing this, doing the actual fueling operations, has been on console since 5:30 a.m. this morning, which means they have all been up longer than that. So they are already going on. They're already over a 12-hour workday at this point. And one thing that can totally get you, even if you think it won't, is fatigue. Fatigue can really be a problem here the longer into things they go, and NASA is very cognizant of that. And we've seen Charlie Blackwell-Thompson, the launch director for Artemis, be very cognizant of that in the past runs for the attempts to fuel the vehicle. So just because we have a fully fueled vehicle at 5:50 p.m. Eastern does not mean we might proceed forward, even if they do develop the plan, because of crew fatigue and crew rest that's needed here. So we'll have to see. Lots of factors are coming into play the longer into the day we push here, and it's not necessarily a vehicle consideration or commodity consideration here, but a human consideration.
Right, and as PAO was saying, Charlie Blackwell-Thompson, the launch director, is actively, like he said, pulsing the team, asking how they're doing, because that is gonna, she's gonna have to decide whether they want to try and execute this test plan here, if they decide that there's engineering value in doing it today.
I'm going to keep questions coming here while we wait for more updates as the team continues to work a plan for terminal count testing. So if you have questions, please tag us at NASASpaceflight in chat, and we'll keep those coming. We've got a couple that have come in already. Jay Fidel says, I saw a timetable from NASA that showed the lunar gateway being set up after the first crewed lunar landing. That is correct. What lander would they use since the moon ship requires the gateway? That is not correct. So to answer your question, Starship, the landing system that has been selected for the initial landings for the Artemis program, which is the moon version of Starship, does not require the gateway. It can dock directly to Orion without a gateway involved, and thus the plan would be for Orion on Artemis 3 to launch aboard SLS to lunar orbit. There it would rendezvous with a waiting fully fueled Starship lander. Crew would get on board Starship, land on the surface, come back, rendezvous with Orion, and Orion returns to Earth with no gateway involvement. The gateway would become involved in later landings. But to answer the question, Starship does not require the gateway. Other questions that have come in here. Roseanne with a super chat question. Thank you so much for your support. Asking, what will we see from a result of this testing? I would say right now, there are some visual indicators that the rocket is fueled. The rocket is venting. You can see lots of venting near the base of the vehicle right now. There's also some venting from the other camera views from near the top of the tanks. Any other visual indicators we can be looking for as the teams progress outside of the audio updates that we're getting from NASA as to where in the countdown they actually are?
No. The crew access arm is not going to swing away. None of the umbilicals are going to detach because they're, for all intents and purposes, although one is technically not, by 0.25 seconds, all the arms are T0 umbilicals, which would separate at the moment the solid rocket's light. So we're not expecting anything to happen there. There's no extra venting that happens. The only real visual change from the camera that you can, from our camera, not the one that you see right now, which is a NASA engineering or operational television camera, actually. On the mobile launcher, but from our camera here, what you will see is the gaseous oxygen vent at the top of the vehicle, toward the top of the core stage. They will close that vent valve just before they head toward liquid oxygen tank pressurization of the core stage, and that will basically be the visual change. Other than that,
And then you'll have the engine gimbal. Now, I don't know whether they're going to show it to us, but we would see
true.
the engine's gimbal, and that would be around 2 minutes and 30 seconds, again, assuming they proceed with this plan.
But visually, that would basically be it.
Right.
Because even on
these are the only
let's
two
just
views. Well, three.
exactly.
We have three views today. We've got this one that Chris is providing to us, and then we have two cameras that NASA is providing to us, and hopefully we're going to get more when we actually get to a launch attempt.
Yeah. Now, to take this a little bit further into like, well, what happens if like we come back and we do this again and they actually get the whole 2 runs that they're talking about down to 33 and then down to and then down to 9.34 before cutting off. 9.34 is technically after the ROFIs, the radial outward firing initiators, or the hydrogen burn-off system will ignite underneath the RS-25 engines. However, there are no ROFIs in place because we are not lighting the engines, so we do not have to burn off the excess hydrogen that is collecting under the engine bells. So you won't see the ROFIs ignite, even though we'll pass the point when they should, and you will not see sound suppression water get activated, which are 2 major visual cues that you'll see in a liftoff, but they don't need to do it here for wet dress, so those parts of the count have been inhibited and will not happen.
There you go.
So basically, that's a long way of saying nothing. Visually, nothing
Right.
will change. Appreciably, yeah.
Let's see here. Other questions that have come through here. James with a super chat question. Are they going to name the capsules like they did with Shuttle and Dragon, or will they always just be referred to as Orion? Will Orion capsules get names?
I don't think they've said one way or the other. It's important to
I
note
would be
Starliners also
shocked
get
if they
named.
didn't.
I mean, I would agree.
Yeah.
But it's interesting. Well, no, you know what? I'm thinking of a whole bunch of things. So, for instance, on Apollo, the Apollo, I believe Apollo 7 and Apollo 8 were command module only missions, and I don't believe that they named those spacecraft. But then they needed to have call signs for the command service module and lunar module because they were flying independently of each other. And so, the rest of the Apollo flights. Now, for instance, like Skylab, I don't know if they had spacecraft names for those, but then obviously the orbiters, the shuttle orbiters got named, and the Dragon capsules are getting named. The Starliner capsules are getting named. So, I agree with Thomas. I would expect the crew will be named for Artemis 2 probably after this mission is completed, and somewhere along the line they're probably going to pick a name for this capsule. Even though I believe this is Chris, correct me if I'm wrong, but I think, is it the first, just this capsule that's not going to be reused, or is it the first 2 capsules that are not going to be reused?
First 2 will not be reused.
Okay. Okay. But I would still expect them to, just because it seems like that's become a convention is to give your ship a name.
Yeah, and Apollo 8 definitely didn't have it. I'm looking up the Skylab missions now, to see if they received if those command modules received names. But 8 and not, but 8 definitely did not. And then once they started flying the LEM is when they needed as you said, is when they needed
Right.
the call signs just to distinguish them. And no, I am not seeing names attached to
Right.
the Apollo command modules for Skylab.
Yeah.
It is literally referred to as Apollo CSM-116. So
Mm.
no, they did not get names unless they
Right.
absolutely had to.
Yeah, and I'm just thinking of like the protocols. Again, I could be wrong, but I'm just like
Yeah.
remembering some of the Apollo 11 recordings that I heard when I was a kid that they actually changed the protocol. So they would call the call sign was Apollo 11 until they got to the point where they needed to distinguish between Columbia and Eagle.
Right.
And it wasn't just mission control to the spacecraft, but spacecraft to spacecraft. And so they didn't use Columbia and Eagle necessarily until they got to the point where they were separate. They were going to get ready to be undocked.
And let's talk, and we've got time. So let's briefly, and I promise Thomas briefly.
No, please continue.
Let's talk about why NASA used to name capsules, then went, heck no, no one's allowed to do that. Then went, oh shoot, we have to because there are two. And then just named the orbiters themselves, except for Endeavour, which was named by school children. And now we've had this swing back, right, of NASA saying, yes, name Starliners, name Dragons, crews get to do that, right? So basically, the capsules got names during the Mercury program: Friendship 7, Freedom 7, Aurora 7, those types of names. And that's what they were referred to. And then Gus Grissom and John Young were assigned to the first crewed Gemini flight, which was Gemini 3. And Gus Grissom, who was on the second Mercury crewed flight, which was the second and final suborbital flight, had the rather unfortunate incident on that Mercury mission's landing of the pyrotechnics on the hatch malfunctioned, and they did malfunction. He was vindicated when they raised it off the surface of the ocean. The hatch system malfunctioned, blew the hatch in rough water, and the craft sank. So he decided, in a tongue-in-cheek, because I didn't do this and I know I didn't do this, but NASA thinks I did, I'm going to name the first crewed Gemini Molly Brown, after the unsinkable Molly Brown passenger on the Titanic and the myth that sort of grew around her. NASA didn't like that, wanted him to change the name of the capsule. He outright refused, so NASA said, fine, nobody else gets to do it after you. And then they got to Apollo, and they had to have call signs, so they were technically call signs, not names. And then NASA named the orbiters, except for Endeavour, and then has allowed the crews to name the Dragons and the Starliners thereafter. So basically, NASA got upset at Gus Grissom, and nobody else got to do the cool thing for a while.
Some of those weird parts of spaceflight history that just have weird stories behind them. But thank you for the question there.
Yeah. Sorry. I was reacting to something else. All good.
Okay. Let's see here. First of all, Paula Miranda with a new membership. Thank you so much for your support there. Question from Mr. Vipitus. Is T0 ignition or liftoff or both? So T0 is liftoff. Also, well, it's liftoff and SRB ignition, right?
Yes. Although if you want to get technical, no. If you want to get really technical, T0 is all 4 of your RS-25s are already up and running and at 100% of rated thrust. I think they're 100 when they're on the pad, and then they throttle up very quickly to 109 after they leave the pad. But T0 is technically light the solid rockets, send the commands to sever all of the T0 umbilicals, lift off. Even with the power of those solid rocket boosters, is still 0.3 of a second after T0.
But that's pretty close.
Pretty close.
It's pretty close.
Since we had time, I said technical. Yes.
Let's see here. Mr. Fabitus also asked, will there be any other rocket flying to the moon before Artemis 1? And the answer is absolutely yes. In fact, the next one, I got to check the launch date because it has moved a couple times, is currently this Saturday because a Rocket Lab Electron rocket will launch what is, depending on your definition, the first Artemis launch.
Yep.
We'll be launching the Capstone spacecraft, which is part of preparing for the Lunar Gateway Station, basically testing out the stability and navigation methods required to reach the orbit that Gateway is going to use. And that's launching from New Zealand this Saturday, early morning here in the eastern United States. That launch is currently scheduled for 6 a.m. Eastern Time on Saturday. And that's going to lunar orbit, so that counts.
And first launch to the moon from New Zealand. Woohoo! Yay!
Yeah, ever.
That's a big milestone. Yes.
That will be very cool, of course. There are also other missions to the moon that are preceding the Artemis 1 mission, most of which are part of the Artemis program, but the missions that are named Artemis refer to the Orion launches. But there is a couple CLPS missions that should launch before... Well, all right, I say that. They were supposed to launch it before Artemis 1 at one point, but they've also been slipping. There are other robotic moon landing missions that are somewhere in the realm of launching this year. I think if the Artemis 1 timeline goes well, Artemis 1 beats most of those, but yeah, off the top of my head, I don't know any others that will beat Artemis 1, but there are other ones coming up soon to answer the spirit of the question.
The Peregrine lunar lander on Vulcan being a notable one that's just sort of waiting on the Vulcan rocket to be ready to launch it.
Other question here. Oh, there's a good one. Philip asking, not Philip Sloss. Philip asking a question for Philip. What is a buy down? He was talking about buying down risk. Do you want to explain what exactly that means?
It's I'm trying to think of how to describe it. I mean, I think it's the idea of you want to perform as much of a test where you're pathfinding as possible, so that even if you have to repeat it, you can make changes based on what you learn in the test, and the risk being you're buying down first time risk. And so an obvious example today is the hydrogen leak that they had today. It's the reason that we're here today in late June, mid to late June, is that they were only able to buy down about a quarter to a third of the wet dress rehearsal test objectives in April. And so they're basically, you want to just keep going through this, because the farther you go in the test, the more you learn, and you're buying down that risk of finding these issues. It's better to find out about those issues, if there are any, as soon as you can. And so it sounds like we might be getting an update.
This is Artemis Launch Control at
Maybe we're
T-minus
hearing
10
an open
minutes and
mic.
holding. I'll make this a brief
There we go.
update. The team is still continuing to discuss this plan. They are now taking the plan to continue terminal count and mask some of the violations that would be thrown due to maintaining an engine bleed, because there's a leak on that line. They're putting it before the mission management team as I speak. Stand by, I'm going to listen in. This is Artemis Launch Control.
Okay. Well, so that means we're getting at least close to a decision, because the mission management team would be, along with Charlie Blackwell Thompson, the launch director, they will be the ones who will sort of huddle and decide what they want to do for the rest of the day today. So, but they've, again, the buy down, what you be buying down is you'd be buying down just the risk of performing something for the first time, and what you and learning something that you don't know already. the more you know, the better off you are. There are known unknowns. So for instance, we know if you're in Florida, we know that you're probably going to have a thunderstorm in the afternoon most of the time. Whereas an unknown is you're just aware of the fact that something's going to come up, and so but you're only going to find out about it if you count down inside of 10 minutes. And so the more that they learn today, the better off they are. And so, I guess I apologize. I'm having trouble sort of drawing a direct line from that philosophy to why they call it buying down risk. But I think it's the idea of the farther they go in the count and the more pathfinding that they do, getting to points in the countdown that they've never got with this ground control system and this fully integrated rocket will help them either in their next wet dress test attempt, or if somehow they're able to get enough information to say, okay, we've collected enough information and achieved enough test objectives to call it, to call it complete enough, I guess. But it is, like they said, it's risk reduction. But I think the risk is it's the risk of performing something for the first time and what you might learn from that.
Right, gotcha. Okay, I'm going to keep some questions coming here. We were talking earlier about crew rest and the fatigue that could come in and how that plays into launch countdowns and things like that. Philip Whitehouse with a question: why don't they swap out the crews after, say, 6 hours? I know obviously the wet dress rehearsal is a multi-day thing, and obviously different teams come in and out on shifts. But so is there ways for them to extend the cryo loading part of the countdown by splitting it into multiple shifts, or is there a reason they don't do that?
Not really. Sorry, not really in this case, and the answer is kind of twofold. One, there's no need to do that because you basically just shift your team so that the prop loading team takes you through the entire prop load. And if we were in a launch configuration standpoint, like trying to get SLS off the ground, we would have violated the 2-hour launch window by now anyway, and everyone would be going home. You don't really want to swap out team members during big critical events like fueling and things like that. You want the same people laser focused on the readings and what's going on and working issues and reading through things with the support from those in the back room. And the important thing to note here is they have a team in firing room 4 that's the actual team controlling all of this. And then they have even more team members in firing room 3 who are also monitoring and talking to them and doing some analysis and all of this different things. It's a huge team that's here, and their specialty is fueling the vehicle and going through it. And then the team that would come in after them is the specialty of detanking the vehicle, getting it back into a stable configuration, monitoring the various systems as you go through the drain and inert procedures. But I mean, think of it this way: like if you're driving down the road and you need to swap drivers, you pull off to the side of the road and swap drivers. You don't, okay, we're going to set cruise control and no one's going to be watching the road as we switch seats inside the moving. You don't do that. And that's a very similar analogy to here is you don't want the added distraction of having to say, okay, well, I was tracking this issue. Now you have to track this issue and it relates to this other issue in these 5 different ways that we've already done.
Right.
That person's going to be lost, 3 minutes after coming on console if they're transitioning during troubleshooting efforts like this. So just keeping the teams the same and just working with the team work limits is more efficient and better than trying to swap out and track and make sure the person coming on console is able to track everything that you have been tracking and talk about it in the same way you've been talking about it with everyone else on the team. So it's
Right.
just easier to keep everyone the same until you're scrubbing, and then you bring in the scrub team, basically.
Gotcha.
right?
Yeah, that makes a
And
lot of
then
sense.
the other thing about the situation is kind of like what we're talking about with risk buy down, because this is we are getting to again, I keep calling it pathfinding, but this will be the first time that the ground launch sequencer, it's new software, it's a brand new ground control system, will count down a fully fueled SLS vehicle. They've done tests with the software in a unfueled state, but this is the first time that they've gone through that they've gotten this far. And the reason that they don't necessarily schedule like a shift change, maybe you could schedule a shift change in a system that you're familiar with or have more experience with. You could schedule it, for instance, after the tanks have been filled. Well, you can see today they've had issues, and so they didn't get to that sort of stable replenish point, which would be the point where they would start thinking about sending the crews out on a crewed launch to get in the vehicle. So they intentionally, because this is the first time that they're doing this, wanted to have their senior most experienced console operators on console all the way from the beginning of tanking all the way through to detanking and draining, where they'll hand over to some other people, or in this case, if they're not able to completely get through that, or they time out. But maybe in the future they would consider doing that, but they're still learning how to fuel this vehicle, and they're obviously trying to learn how to execute these automated processes and get all the way down to as close to ignition as they can, was one of the major objectives of this test. So it's some of it has to do with this first time situation that we're in.
Yeah. Some more questions that are continuing to come in here. And again, if you've got questions, we're continuing to answer those while also providing updates and relaying updates as we get them from NASA regarding today's wet dress rehearsal. If you are just joining us, the main issue that is being tracked this whole time is a liquid hydrogen leak on a quick disconnect on the core stage side. And that issue has been continuing to being worked. Teams are looking at a plan to potentially proceed into the terminal count despite this issue in order to get more data before they conclude the wet dress today. It does sound like that would prevent some test objectives from being reached, but that doesn't mean that they can't get more checked off if they can get into terminal count safely, so they're working on that. That's why the clock is still holding at T-minus 10 minutes, and we will keep an eye on that and provide more updates as we have them. But we've also been answering some questions, and we've got another one here from Harry Young, who asks, if on launch day SLS pulls a Delta IV and fires the rofies without igniting the engines, what is the process for replacing them? Can it be done at 39B? Would it require a rollback? What do we know about that potential scenario?
It would be so. I mean, they had that happen a couple of times on shuttle, and so they would basically replenish them, so to speak, but they would be able to recharge the hydrogen burn off igniters, and the same thing with the pad water systems too. They could obviously refuel or reload the water tower and recharge those systems. It's just how long does it take to go in and replace the Rofi cartridges? I think is it's probably not something where I would be very surprised if you could fire them more than once. Now, having said that, the system they had at Stennis, for instance, was pretty robust, so maybe they can. But I would assume that if they got down there and then stopped before the engines got start commands, that they'd have to scrub and do replace those, go out there and replace them.
Right. Gotcha. Some other questions and some super chats that have come through here as well. Mars Labs with the $10 support, appreciate that as well. Stefan says the lander on the moon, aka Starship, is going to be way bigger than the little raft Orion to get there. Isn't that weird when you think about it? I mean, when you think about it, the lander does a lot more energy changes than Orion. Orion pretty much just gets thrown by SLS to where it needs to go, whereas Starship needs to do a landing, then go all the way back to the moon's orbit. I guess Orion does have to do the burn to get back to Earth, but Starship also is going to be carrying more than just the people. Orion pretty much is there to carry the Artemis crew, but Starship might be sitting in lunar orbit with experiments, other supplies, other cargo that needs to go to the lunar surface, in addition to the astronauts. So there's also other capabilities there with the lander. But I see the spirit of the question.
I've always said though that if you showed Werner von Braun an image of Orion and Starship docked to one another, and told him it's the bigger thing that that goes down to the moon and comes back up, he'd probably be like, "What? You inverted it? Like that's the launcher." But
yeah, that's funny. Jim Cavett with a super chat support. Appreciate the support there, Jim, and thank you to everyone who has tuned in for our live coverage today. Glad you're all enjoying it. Please feel free to keep sending questions our way, and we're going to continue answering as many as we can as the NASA teams work through today's testing. Another step towards the Artemis 1 launch to the moon. Everyday Space Nerd with a question: what is the difference between Block 1B and Block 2 SLS? So right now, just to back up slightly, we're looking at a Block 1 SLS, which is the configuration you see now with the solid rocket boosters that are basically solid rocket boosters, and the ICPS, the interim cryogenic propulsion stage, is the upper stage, which is basically a modified Delta IV stage. This vehicle only capability is basically to launch Orion to lunar orbit. And then they're going to evolve to Block 1B, which will have the exploration upper stage, so swap the ICPS for the EUS, and that added capability brings more upmass capability and the ability to bring co-manifested payloads, which is going to be things like gateway modules. They could bring a logistics module to help bring more cargo to gateway, to be loaded onto landers and things like that. And then Block 2, I believe, is a booster evolution. So take the current solid rocket boosters and evolve them for higher performance. Are there other changes that I've missed or other key points that I missed, Philip?
No, I think you got it. That's basically, we were talking about this during the rollout stream. These boosters will be replaced by, they're calling, it's a sort of a it's called the BOLE, which is an acronym which stands for Booster Obsolescence and Life Extension, but it actually replaces these boosters with composite cases and also changes the propellant. So they're just higher performance boosters, which will give them a little bit more payload capacity to the moon.
Right, gotcha. And I should also mention the other difference that will come with Block 1B and continue with Block 2 is the new mobile launcher.
yes,
Right. Basically, yes. And of course, there's a lot of
time of it.
Yes,
Yeah.
yes. But yeah, it's a taller. The EUS is a larger. In order to EUS will basically increase the payload performance of the rocket by about 10 metric tons. And so this vehicle that we're looking at here can throw about 27 metric tons to the moon. And so EUS, again, depending on how the performance that they actually get out of it, should be anywhere from you should increase that to 37 metric tons and perhaps a little bit more. But it's a taller, it's a much bigger upper stage. It's got the same diameter as the core stage. And it just gives the vehicle more flexibility too, in terms of, we're talking about launch opportunities. So this vehicle, the Block 1 vehicle, can only launch to the moon about half the time in a given month. Once you get to the EUS, and the Block 1B configuration, there will be other factors that affect a particular launch window for a particular mission. But for instance, this mission, if you had a Block 1B vehicle to launch it, you would pretty much be able to launch any day of the month. You would still have issues, like there are other constraints like Orion eclipse constraints and reentry constraints, but that's one example of some operational flexibility that you'll also get for US. And it's also, again, it's designed for this vehicle versus the ICPS, which was intended to be essentially a off-the-shelf upper stage.
Yeah.
Gotcha.
Yeah, and then again, one of the long pole items that we've got for that is the umbilical tower, which has to change the entire mobile launcher. That has to be built anew for the Block 1B and beyond. And just briefly, it is years behind schedule, double the original cost estimate. The company that bid for it basically told NASA, "Just kidding, double." After they won the contract. And the Office of the Inspector General report that just came out about it is quite interesting and worth a read. It definitely falls very heavily into the hand of those who are saying these cost overruns are ridiculous. When companies bid a certain amount, they need to eat the additional costs that they didn't put in there to win the contract, because it's kind of concerning that a bid for a $430 million mobile launcher is now close to $1 billion instead of $430 million. That's not like, oh, we forgot this one component, so it's going to be, 50,000 more than we thought. Like that's not falling into that realm. So, yeah, cost plus contracts can become a problem here.
Right. Yeah, I was amazed. I was amazed that the NASA administrator, Bill Nelson, I was just amazed at how explicitly critical he was of the situation with Mobile Launcher 2, because he was basically testifying to Congress under oath. And so you don't usually hear such blunt language from the NASA administrator. And so he was very unhappy with the situation, and he mentioned the cost plus contract type specifically, as one of the, I think he said some words to the effect that they have to basically eat this contract, even though because it's a cost plus contract.
Yeah, no wiggle room for him. Yeah.
Yeah.
Keeping the questions coming here. Brad asking, will they be turning on the sound suppression system for these wet dress rehearsals?
Negative. No need for sound suppression, since you are not lighting anything that makes the sound that you would have to deaden. So, and since we're not igniting the RS-25s or the SRBs, no need for sound suppression water. And same reason why the ROFIs, the radial outward firing initiators or hydrogen burn-off system, will not be utilized for the wet dress rehearsal.
All right, gotcha. Thank you. Another question, Discovery asking, how come it is holding for 2 straight hours? I can provide that update. Basically, this hold was supposed to last 30 minutes. It is a built-in hold at the 10-minute mark prior to entering terminal count. However, teams have been working on a hydrogen leak issue with a quick disconnect on the core stage for all this time, and so the hold has been extended. This is not a planned thing. It is part of the team's troubleshooting an issue. So.
Right. This countdown is simpler than shuttle countdowns. There are 2 built-in holds. There's one at T-minus 6 hours, 40 minutes, and they hold there for 90 minutes. And basically that's the point where they decide, are we ready to tank the vehicle? And then they have a 30-minute hold it's supposed to be a 30-minute long hold at T-minus 10 minutes. And they're deciding at that point, are we ready to launch the vehicle? i.e., are we ready to start the clock and begin the terminal count and count down to 0? And so the thing is, today when we got to this hold, they've spent quite a bit of time, and the question still remains: are we ready to pick up the count at 10 minutes and at least count down towards 0, like they would on a launch day? So the reason that we've been holding for an extra 90 minutes is because, as Thomas said, they're doing some troubleshooting and they're trying to get into a configuration and come up with a rationale to count.
Right. Keep some questions coming here. Interstellar asks, why is the installation colored orange with respect to any other color? I know it's the same installation that they used on Shuttle. The core stage was adapted from the Space Shuttle external
Yes.
tank, but do we know why it's actually orange?
Well, it doesn't go on orange. It actually goes on a much lighter shade of tan and beige. And it becomes orange due to UV radiation exposure. So just like your skin tans in the sun, so does the SLS's foam. And it's spray-on insulation foam. It is slightly orange. It's like a yellowy tan when
Hmm.
it first goes on. But then it actually turns the burnt orange that you're seeing because of
Right.
exposure to UV radiation.
Yeah. I mean, it's actually kind of amazing. I've seen some articles right after they've gotten either manually sprayed or robotically sprayed, and it's very light. It's almost like a light cream. I mean, just almost off white color. And the other interesting thing about it is that it does eventually kind of saturate. Like it gets to a point where it won't really tan anymore. And I would say the core stage, which was outside for almost a year and a half at Stennis, continuously has reached that point. And we're seeing another that conical section right above the core stage had not been outside for very long, and I think it's reaching that saturation point now too. So hopefully one day they'll actually get to the point where these vehicles won't have to spend quite so much time outside before they're ready to fly.
Right. Yeah, this one between the green run and obviously this wet dress campaign gets plenty of time in the sun. And it's funny if you see there are some pictures of the space shuttle, like there's space shuttles on both 39A and 39B, and you can always tell which one rolled out
Right.
more recently because it's the one that's not as tan.
Right. Yeah. There
Yep.
were some tanks that had spent a lot of time outside.
Which, while we're talking about tanks and foam, that's why they painted the first two tanks for the shuttle program, was to protect them from UV radiation for the planned prolonged pad stays. They didn't really have a good grapple on how the spray-on foam insulation would degrade while it was outside for prolonged periods of time, and they knew those pad flows were going to be 4 months long or longer. So they prepped for them, and then once they sort of said, "Okay, like we know we're not going to need that anymore," is when they stopped painting them. But the plan was always to stop painting them, contrary to popular belief.
There you go.
And now we know about the foam, so we know we don't have to paint it. We know it's fine. We know
Right.
how it degrades and doesn't. So now it's fine, and we don't have to do anything with it.
Gotcha. Another question from Jim who asks, are the solids loaded or just dummies? Nope, these are the real thing. Those boosters are fully loaded with solid propellant and will be the ones used for a real launch of Artemis 1. They do not get replaced.
Yeah. So when we say fully fueled, we mean it.
Yeah,
Yeah,
it is
fully
actually right
and
now. It is fully fueled. Actually, I don't think the camera that the up close camera that we've got today. I'm not sure if you can resolve it, but if you get up close enough to the cases for these boosters, they actually have a stencil on them that says loaded. So
Yeah.
versus I don't know if the inert ones say inert on them or not. They don't. They have a different stencil on them, if I recall correctly. But it does say loaded on the side of the cases.
Does indeed.
Another question. Why are the bottoms of the RS-25s frosty?
Because they are thermally conditioned. So there is hydrogen that is flowing through them, or rather will be did they stop the bleed into the engine since they can't get the bleed out of the engines right now with the leak? Philip, do we know?
Just the hydrogen, but I
Just the
think
hydrogen,
we're still seeing gaseous oxygen, which they can just vent into the air, as we're seeing, up at the top of the vehicle here. You can see a little bit of that in the view here. You can see a little bit of vapor coming off the top of the core stage. But yeah, the hydrogen bleed has been stopped.
Okay, yeah. But basically, the thermal conditioning of the engines with liquid oxygen and liquid hydrogen is what causes the outside of them to sometimes get a little bit frosty. How the air sort of circulates under there can also trap it and make it a little bit colder, which would allow, change the various atmospheric conditions that would allow for frost to form. It's also very humid here. today. So that's the frost that you're seeing.
And it's
And when
only
they
on the very,
light, they get
we're actually
frosty.
looking at a camera view now because NASA did switch back to this engineering camera. It's just the very bottom of the engine bell.
Right, and it may just also be a factor,
Yeah.
which is you can see the gaseous oxygen. I mean, and it's cold enough. It's in gaseous form, but I mean, we're still talking about almost 300 degrees below 0 Fahrenheit, and approximately, in the same ballpark Celsius. But since it's venting out these drain lines at the base of the nozzle, or at the at the exit plane of the nozzle, that's closest to to those areas, and so they're closer to that cold air and cold venting, and so that may be why you have a better chance of frost accumulating around the bottom.
But totally normal. And in fact, when they ignite for launch, ice usually covers the entirety of the engine bell when they ignite. Yeah.
Right.
Which is one of the great parts of rocketry. It's like 3,000 degrees Celsius on the inside of that thin little piece of steel, and it's freezing on the outside of it. Yeah.
Right.
So, some more super chats have come in here, so we should get through these quickly because we want to thank everyone for their support. Roseanne says, just a thought, wow, Von Braun, I'm 68, looking back to the experiments of the 50s that led us to where we are. I'm not capable of imagining where we will be 100 years from now. Roseanne, thank you so much for your support, and definitely an exciting future when you consider how far we've come so far. Let's see, Greg with a super chat. If the shuttle orbiter was about 100 tons side-mounted versus inline on smaller tankage, only 3 shuttle engines versus the 4, why can SLS Block 1 take only 95 tons to LEO? What was the mass to orbit of shuttle? Less than that, wasn't it?
Depends. In terms of deployable payload, the shuttle could do. This is what's always weird about this question. Okay.
We're standing by
T-minus
for
10 minutes
NASA.
and holding.
There we go.
This is Artemis Launch Control. I'm Daryl Nail with NASA Communications with an update now. And when we last briefed, the mission management team was listening to a recommendation by the launch team to move forward with terminal count, which is a count from the T-minus 10 minutes that you see on your screen down to a cutoff point, a pre-planned cutoff point at T-minus 9 seconds. There's an issue that we've been discussing, and that was presented to the mission management team, and there's a hydrogen leak. Stand by. The mission management team just jumped on the loops to say they are given a 5-minute warning. They're about to do their poll. So they're going to poll on this plan, and Chief Engineer, SLS Chief Engineer John Blevins out of Marshall Space Flight Center says he had no hardware concerns over masking some of the violations that will be created by allowing the engine bleed to continue during terminal count. That's not a nominal operation. Normally it'd be sealed. The core stage hydrogen engine bleed would not be shut off. And so that would normally, if it were, it would bring the hydrogen tank up to flight pressure. So in order to prevent the pressure from rising, they're going to leave the bleed line open. Now, there was a lot of discussion about whether the GLS, which is the ground launch sequencer, this is the computer that is controlling the launch operation and doing the commanding and controlling, all of it for the final 10 minutes, will get to this moment. There are thousands of complex operations this computer is doing in a matter of seconds. But again, the chief engineer does not believe the software. He does believe the software would get down to 9 seconds which is the moment just before the go for core stage main engine start. That's where this team wants to get. They want to count this down. They want to get to that moment, learn as much as they can about this vehicle before it cuts off at 9 seconds. If they do this plan, and we're going to have a mission management poll here in just a couple of minutes, and then we'll have several more polls. The NASA test director will poll, and then the final poll will be Launch Director Charlie Blackwell Thompson. The moments to look for will be at T-minus 4 minutes and 40 seconds. This is when the ground launch sequencer will check to see if the liquid hydrogen high flow bleed is closed. It's going to be masked, so it's not going to see it. Another moment to look for is T-minus 33 seconds, another checkpoint, if you will. The RS-25 engines, which you're looking at now in this picture, you can think of them as having their own autonomous launch sequencer on board. They have their own computers that are checking, their software is checking parameters, looking at conditions, and if the high flow bleed is still on, that's going to create some data that could cause one of them to throw a cutoff. So to throw out an analogy that I heard, it kind of like a bad check engine light, if you will. Not the one that you can keep driving on, but the bad one where you've got to stop. So the plan was recommended by Launch Director Charlie Blackwell Thompson. She said it was a good plan. She says there are protections in place to keep the vehicle safe, and she recommended proceeding during a briefing with the mission management team. And this will be one run. Charlie Blackwell Thompson, checking with her team, says it's been a long day and that one run should do it. So we're just a few minutes away from that poll. I'll brief you when that poll happens, and then we'll take you through the count and the different milestones as they begin, or as they happen, rather. We should have that for you in a matter of minutes. We're standing by again for the mission management team poll. This is Artemis Launch Control.
All
So a
right,
couple things there, yeah.
Go for it, Chris.
Yeah, so a couple things here. The plan that we've been talking about 2 runs through terminal count is out. It's 1 run. So basically what they plan to do, if I got this correctly, and Philip check me, is if everyone polls go, they will pick up the count from T-minus 10 minutes, and our first major milestone to look for is at 4 minutes 40 seconds when stand by for an update from NASA.
This is Artemis Launch Control at T-minus 10 minutes and counting. Want to make a correction to what I just said. The bleed valve will be left open. That is not the condition. It will be closed. The bleed valve will be closed. Normally, under a nominal countdown, that bleed valve would be open. Okay, so again, the bleed valve on the liquid hydrogen will be left open. Will be left closed. It's been a long day. It will be closed. In a nominal scenario, it is open. It will be closed. I want to make sure we are clear on that. Again, by closing the valve, normally when you go through the countdown, that engine bleed is open, and it's conditioning the engines that you see right there for launch. Getting them down to the proper temperature to light them. But if it's closed, that's going to change that parameter. Again, my apologies for that. This is Artemis Launch Control.
Sorry,
All
Daryl.
right,
We're all there with you.
Yeah, we're all there, and I'm with Daryl. This is confusing in some regards, and plans are changing on the fly here. But basically, what it is going to what you are going to do is you're going to be, if the poll is complete and good, they'll pick up the count at T-minus 10. They will plan to count down and do one run through the terminal count.
Yeah, like a
And
consolidated run. They're
yes,
consolidating the two runs into one.
yes, and that means, but there are a couple things to look for. 4 minutes 40 seconds is when the systems will start doing their check, which could be the moment that it indicates, wait a minute, something isn't right on these engines, and the system might flag, hey, this isn't right, cut off. They're trying to mask all of those, but again, the system is going to be doing this. They're inserting these lines of code into the software right now to mask them. So if they don't get something completely right, it's possible the system could still go, whoa, we're out of configuration, stop. They're hoping that doesn't happen, but it could happen at 4 minutes 40 seconds, and it could happen again at 33 seconds when the ground computer goes to hand off to SLS's flight computers. And then they will attempt to go all the way to T minus 9.34 seconds, which is the cutoff period right before all the valves would begin to open on the engines and start dumping the propellants in for the ignition sequence. So that's the basis of it. 2 runs are consolidated down into 1. So we'll pick up the count at 10, count to about 90 seconds, which is where they plan to do a hold demonstration, to make sure that they can demonstrate that the vehicle can hold in a pseudo flight ready condition and not have anything happen. Then they'll plan to pick back up from that 90 seconds and just count to 9.34. But the trick the trick here is that
I'm not sure they're going to hold. I'm not sure they're going to hold in this configuration. I would not be surprised if they just try and go down as far as they can go down. So we'll just have, like you said, we'll just have to see whether or not we have a hold. And the commentators should be able to tell us whether we're holding due to this engine bleed condition, or whether they're going to try and pick up that test objective or not.
So while we're going to wait for the teams to complete their go, no-go, and hopefully get into some terminal count testing to wrap up the wet dress rehearsal for today. So again, if you're just joining us, the teams are about to enter that poll to whether to proceed into the terminal count while masking the known liquid hydrogen leak issue so that they can complete some more test objectives before they wrap up today. Now, what's not known is exactly how that would play out. Even assuming everything else goes perfectly, it's not known whether they would need to do another wet dress rehearsal to fully clear the rocket to proceed into a launch campaign, but that's a question we're not really going to know the answer to until after the testing is finished anyway. So, in the meantime, we're going to focus on what they can get done today, which will hopefully include some terminal count. And so we're going to rapid fire some more questions here while we wait for that go, no go, so that once they do poll go, we can focus on the terminal count that's going on. So a question here, when they do conclude the testing, how long is the process to drain the tanks and safe the vehicle?
About a day. It'll take a handful of hours to drain the stages, and then it'll take another handful of hours to inert them, and then at that point, then you can have the majority of the launch team and the launch crew or ground crews come back out to the pad and start working on the vehicle.
Gotcha. Another question here, do the solid rocket boosters on SLS have any steering ability? They have thrust vectoring, right?
Yes. Yep. And in fact, they're really just like shuttle. They are the primary steering mechanism during the time that they're firing. Just again, based on the amount of thrust, they're providing about 80% of the overall thrust. So, you would be having you don't want to get into a force fight between the core stage engines and the boosters.
Yeah, those core stage engines, in addition to being lower thrust than the solid boosters, also the boosters have the torque arm benefit of being on the outside of the vehicle, right? So
bigger
the torque
levers
for rolling the vehicle is greater.
Longer levers.
Yes. So good question there. Thank you, chat, for all of your great questions so far. We hope we've been able to provide some pretty good answers. Let's see. Also, some super chats that have come through here. Soritis says they should have made it pink, hashtag X15. Have y'all seen the pink X15 that they're talking about? Because it looks ridiculous.
Yes,
No.
the ablative thermal
Yeah,
coating that they put on those the gosh, I can't remember, but the one that had the drop tanks on it too. Those
yeah.
big drop tanks.
Chris, you got to look
Um,
up the pink X15. It looks like a big giant like pink eraser, but it's
Oh
an
my gosh.
X15.
Okay.
It's possible
Okay.
that it's possible it
That'll
had
be fun to look at.
that kind of consistency too
Right,
before
yeah.
it chars.
EXO with a new membership. Thank you so much for the support. Frank with a super chat. Appreciate your support. And Julio, I believe is the name, says time to be steely-eyed missileman. I poll go. Appreciate the support there as always. Joshua Green with a question. Can they reuse the fuel for a future attempt, or do they just vent it to atmosphere?
No,
If
they
they
will drain it.
they can
They'll
use it.
they'll drain
Yeah.
it back to the storage spheres, but they won't get back. So they're losing all. Of course, they didn't do so. They lose a lot of it through the engine bleed, but since they aren't doing it today, it's quite possible that they're
That's
really
true.
only going to be losing the boil off. So they will they have it perhaps won't lose quite as much, but they still won't have enough to turn around tomorrow. Although again, that's really not a possibility in this situation.
Gotcha. All right, that actually catches us up on the question queue and the super chats. Thank you everyone for your support and for tuning in for our live coverage. If you are just joining us, this is live coverage from the Kennedy Space Center in Florida, Launch Complex 39B, where the first ever SLS rocket is undergoing its wet dress rehearsal.
And
Right
it's
now,
going to be interesting to
okay.
see how to see what happens here, because this is a little different than the plan where they're consolidating these two attempts, and then you also have this situation with this off nominal. The vehicle is not in not going to be in a launch configuration exactly, and so I'm kind of curious to see whether they will do. As Chris was saying, they'd originally planned in the first run to demonstrate 3 minutes of hold inside 10 minutes. So they would stop somewhere between 6 minutes and T minus 6 minutes and T minus 1 minute 30 seconds. I'm as I was saying, I'm not so sure they're necessarily going to do that in this case. And then, as we were also talking about, they planned in the first run to only to stop at 33 seconds. But what they're going to do now is they're going to hopefully they're not going to stop at 33, and they're going to attempt to hand the vehicle control over to the vehicle computers, and that's the 33-second point. And then the vehicle with the flight computers in the core stage will take over control of the vehicle command and control, and the ground launch sequencer will still be in control of all the ground systems. And it'll just be, it'll be very interesting to see, as they were talking, as the PAO commentator was talking about, they're not totally sure if they're going to, if they will be able to mask out all the readings and get all the way down to 33 seconds, let alone all the way down to 9 seconds. So assuming the mission management team is go and Charlie Blackwell Thompson, the launch director, is go, this will be really interesting.
All right, well, we're looking forward to it. Again, we're still waiting for the result of that poll, so we'll give that as soon as we have it. Really quick, since we are going to get into the business end of the countdown here, and like I just said, we kind of just recapped where we are at this point and what we're hoping to get to see here shortly. I want to go around the horn and just introduce the voices you are hearing. My name is Thomas Burkhart. I'm a news director here at NASA Spaceflight, and I'm offering some commentary, pulling some questions for us today. I am also joined by, out in the field, Mr. Chris Gephardt, who is the Assistant Managing Editor at NASA Spaceflight. He is out there at the press site at Kennedy Space Center offering the camera view you see right now. And Chris, thank you so much for joining our coverage and offering some commentary as well today.
Indeed, anytime. My pleasure.
And then back in the studio, the other voice that you're hearing from NASA Spaceflight is NASA Center's editor, Philip Sloss, who is our resident SLS expert. Philip, thank you for all of your insight and for joining us today.
No problem. This is as I said, this is going to be interesting, even if it is not sort of as planned. This should be interesting if they decide to go ahead and do this.
I know this is kind of a fun game of like, watch the clock. Where does it stop?
Yeah, it's a simulation in a way.
Now.
Yeah, this is like, it's like a Kerbal simulation.
It kind of is, and just for everyone's awareness, like I'm gonna have my eye on the countdown clock. So if it stops for whatever reason, I will say, okay, the clock has stopped at, and just let that know. It might not be perfectly synced. I think our cameras are perfectly synced with real time, but in case they're not, you might hear me say it stopped before you see the clock stop on NASA TV or our broadcast. But that's part of that's part of why I'm here is to watch that clock and see when things happen. Yeah.
And the clock that you do see on our overlay is directly from the NASA official feed. So that clock will react, with the stream delay, like Chris said, to whatever the NASA ground teams are doing. So that will give us a idea of how far they exactly get.
Right.
Anyway.
And another thing, again, this is the first time that they're going to do a terminal sequence with this version of a ground launch sequencer, but it is possible that we'll see a similar type of behavior as we saw during shuttle, which is if they have a violation come up and they're between GLS milestone points, which are basically hold points, we hopefully will hear the commentator basically say they've seen a violation and the clock will stop at the next GLS hold point. So there are specific hold points between T-minus 10 minutes and T-minus 90 seconds, and really even T-minus 33 seconds.
Mm-hmm.
So it won't just stop it won't necessarily just stop immediately. So hopefully we'll get some advance warning if that happens.
Right. And just a couple things there. GLS stands for Ground Launch Sequencer. It is the ground computer, the part that does not lift off with SLS, but that is controlling, right now is controlling everything, including the vehicle. And then 33 seconds is when that handoff from GLS to the flight computers takes place. And then what Philip was saying, the reason we don't just stop a countdown in terminal count, no matter where it is in the sequence, is because there are stable hold points, right? Your vehicle you might be in the process of activating the core stage APUs, auxiliary power units. When a hold condition pops up, you still want to go through and get all 4 of them up and running. And then once all 4 of them are up and running, stop and hold later, right? Instead of interrupting the start sequence of various things. So that's why there are specific hold points. And like Philip was saying, if they need to hold, but they're not at that point, you'll hear countdown clock will hold at T-minus 4 minutes due to a failure or something like that. If we were actually hearing the launch audio loops.
Right. And so this of course we wanted to hear, we were really hoping we would get to hear the countdown net audio. But it actually would be even more valuable in this case.
Oh my gosh, I know terminal count is so valuable to have the comm loops. Yeah.
I find it interesting because this is one of the only vehicles like Shuttle that has this sort of additional flexibility. Whereas you see with a system like the Falcon 9 system, they make that system so reliable that you really don't see a lot of countdowns hold inside 10 minutes, unless it's, again, for something that's outside their control, like a range issue or a weather issue. But this vehicle is more complicated, which, again, you could, say may have something to do with reliability, but they do have a little bit of flexibility with this system that if they stop, they can talk about it, they can make some adjustments perhaps, and they might still be able to then resume and continue to count further down in the countdown. So if they stop, even in this test configuration, it's possible that they're not going to just stop for the day. They may see if they can continue farther down if they don't get all the way down to 9 seconds.
Yeah, and sort of like just picking up on the Falcon 9 thing there, exactly what you're saying, right? A lot of the times we do just hear cutoff, but it's important to note too that there are stable points at where they would cut the auto sequence for a Falcon 9 as well. We sort of saw that on display with Bob and Doug on Demo 2, where they didn't want to interrupt liquid kerosene loading into the second stage. So they decided to make the decision point in the interim when they were transitioning between those two commodity fills. And we've seen several times for weather and range violations when we've had cutoffs of the Falcon system where they will say, okay, it's cut off. Okay, we've scrubbed for today, but the count will continue to this point, at which point we will stop and recycle. So very, very similar across those systems, just like you were saying, Philip. SLS sort of has a much wider range of hold availabilities in its terminal count than some of the other systems that we've seen. And of course, Atlas and Delta don't have any ability to hold in terminal count. It is an automatic cutoff and recycle to the T-4 minute mark for them.
Right, and we also and just also to point out for the audience, there is a point of no return in the countdown where which is T-1 minute 30 seconds. So if we hold after that point, the only option they have is to recycle. Before that point, they might be able to continue, but if we were to get some sort of a cutoff after 1 minute 30 seconds, they might be able to go down to 33 seconds, for instance, but they're still going to have to recycle. Yeah. It's similar to what the kind of situations that Chris was talking about.
Yeah, and to be fair, a lot of that under 90 seconds, let's explain that for a minute. A lot of that under 90 seconds has to do with the thermal conditioning of the main engines. They have to be inside a start box, right, so to speak, in a particular temperature range in order to ignite. You also have liquid oxygen drain back hold time because liquid oxygen is draining down into the hotter feed line, so it's evaporating and turning to gas more quickly. So you just have so many different constraints once you reach T-90 seconds that you basically need to stop, recycle, and go back, undo all of that, so that you redo all of those steps in the correct sequence so that you haven't put one part of the vehicle out of the alignment that it needs to be in to actually facilitate an effective liftoff. It's not just under 90, we don't feel like going.
Right.
There's a major technical reason for it. Yeah.
Right. Well, you have those limits, and then the other reason that they have 90. In shuttle, that point was 31 seconds. For SLS, it's 90 seconds, and the reason it's a little bit earlier is because that's when they do the power transfer. The core stage goes to internal power at 90 seconds, and that's that has a very limited life. And so if they need to stop, then they recycle and recharge those batteries back and top them off to full charge. So but all of those other things like oxygen drain back, hold capability, and things like that, I believe they still have all of those for this system, since it's a derivative of the shuttle system.
Well, we continue to wait to the result of the go no-go poll for terminal count, which we should be getting hopefully soon. Quick question: do they have to drain the hydrazine from the solid rocket boosters when safing the vehicle?
Well, I guess there's two ways of answering that. Normally they will, and they'll do it. They won't do it as a part of a launch attempt, but they will deservice the hydrazine before they roll back to the VAB. Now, in a emergency, and I wouldn't call it necessarily, but again, we're in the middle of a hurricane season now. If they needed to roll back immediately, they might not do that because they just don't have time. They want to get the vehicle back into the VAB. But normally they will deservice the hydrazine in the solid rocket booster hydraulic power units before they roll back.
All right, thank you, Philip.
This discussion's taking a little longer than they were advertising, so we'll be interested to see, because
say anything, but I think you're
Chris,
right.
and Chris, it's that Chris keeps, that point that Chris made about the crew time. I mean, it has been a long time, and so now I could also say I wouldn't be surprised again if the launch team is really excited, even after a long day, to do this terminal count run, because like this is as close to the real thing as they're going to get to the real thing. So and so, you know, this is I'm sure they're tired, but I'm sure that they want to see what happens, you know, and obviously they're ready to act if they need to do any sort of manual overrides. But they've done so many simulations. You know, as we were saying earlier, this is the first time the vehicle has been fully loaded, and so, you know, I think it's a question of, do you feel you're tired, but are you more excited or are you more tired at this point? And that might be that might be part of this longer discussion, is that the management's having, is, you know, do we want to rely on that or not?
Yeah, we're still standing by for an update on NASA with regarding that go no-go poll. We'll keep listening in, and we will stop talking as soon as we have that, but we don't have it quite yet.
And entirely possible, too, that we will not hear that Daryl Nail will simply report the results of it.
Right.
Well, yeah, I think that's probably what we're expecting, but we're still listening in for when he can report on that, yes.
Right. And I mean, typically that's on the terminal countdown net.
And you know what Philip was saying there is very important, because while NASA, you know, has a way of making complicated things look very easy, you know, that in itself is a testament to the team, but it's a testament to the team knowing, like you were saying, Philip, when to work, when you're actually okay to work, and when your adrenaline might be telling you are, but you are in fact very tired and in no real condition to deal with emergency situations where you have to think very clearly and very quickly about what to do and how to work through procedures.
Really quick, we're still waiting for this go no-go update, so I'm going to take a very quick opportunity to say, if you would like to support what we do, there is Artemis 1 merch in the store, as well as some other new items related to whether it's SLS or any other rocket program. I appreciate all the support everyone sends our way, and if you are looking for a way to support what we do, the shop at NASASpaceflight.com is a great way to do it, and there's plenty of orange rocket merch available on the store, as well as your favorite shiny rockets from down in Texas, and a couple other rocket programs that you see us cover here on NASA Spaceflight. That's the at nasaspaceflight.com/shop to check out all of that new merch. There's new merch coming in all the time, including for your favorite orange rocket. So please feel free to check it out if you haven't already, and that's it for the merch plug, I promise. See if we have any more questions coming in here, as we are still waiting for that go no-go decision.
I can do I saw somebody asking, can they come back tomorrow, and they cannot. The minimum would be a 48-hour recycle, but you'd have to think.
Launch.
There we go.
Launch control, T-minus 10 minutes, and holding. The mission management team has been polled on the plan to move forward with terminal count, and they gave a go. So again, the mission management team, the MMT as it's called, is go for terminal count.
Next would be the launch team, I believe.
Right, there's multiple go no-go polls, right, that they have to get through?
Right. I think it's just there's two main sets. So if I recall correctly, MMT, and then they go through the launch team positions.
Yeah, I think they broke it out into 3 this time: mission management team, NASA test director, and then launch director. Right. I think I caught that NTD would poll, and then Charlie would poll as well. NTD,
okay, no, you're right. You're right. That's right. They do the NTD poll, and then the launch director does her poll, and that's a broader community. And I think the MMT chair is pulled in Charlie's poll.
But the first poll then, the mission management poll, is go, which is a good sign for getting into terminal count.
Yeah, I hope he's going to give us a little bit of a heads up that when they're going to pick up. We can see the
update
clock,
was only that they have
but
hold go, so we don't have a time frame for when the hold will actually be released. So again, if you are just tuning in, the mission management team, which is the highest level poll here, has polled that they are go to proceed into terminal count, and the significance of that is not only just proceeding with the test, but they are still masking a liquid hydrogen leak related to the core stage. And basically they're going to tell the flight computers to ignore that and continue with the test so that they can get more data before they finish today's testing. The teams have worked on a thorough plan to make sure that that is safe and doesn't pose any risk to the vehicle or anything like that. There's a couple points in the terminal count where normally the flight computers would check that that particular quick disconnect is operating properly, and so it's possible at those points that the countdown will hold automatically if they have not completely masked it, and the computer goes, "Wait, hold on, that's not right," and that's kind of an okay result too. However, for the purposes of the test, the teams want to get as far in the countdown as they can to get as much data as they can before they have to finish. They have to drain, safe the vehicle, and evaluate whether another wet dress rehearsal is necessary to complete all the test objectives they need to. So what we're waiting for now is an update on when the hold will be released, which could come after a couple more polls because there's a test conductor poll and a launch director poll like we just talked about. No, they did not provide an update as to when those polls could take place and how quickly they can get to actually releasing the hold. But the first mission management poll has polled go. And then there will be that hold released from T-minus 10 minutes, and they'll get as far down in the countdown as they can, potentially as far as T-minus 9 seconds. And then after that, they would move into draining and detanking. They also confirmed earlier that there would not be multiple terminal countdown runs, as was the original plan. Because of how long the teams have been on console today, they are going to do one run today. And again, the questions about would any of this require additional wet dress testing after today, that's something we won't really know until they finish the testing today, look at all the data, and figure out any objectives that they need to go back and do again before they can roll back for final launch preparations. So we'll keep you updated on all of that, but right now we're just waiting for another update from NASA's side regarding what the timeline for getting into terminal count will be here.
Yeah, and it's a good note too, that just because the mission management team has pulled go does not mean that every individual station might pull go, right? I mean, there's probably a good indication of that. I'm sure Charlie and the NTD, the NASA test director, did informal polls going around, but that is not to say if something comes up that someone else might go, yeah, I do have a problem with that. Now they've been talking about it, so the odds of this happening are low, but it's not necessarily a, yeah, just because the MMT said yes, everyone's now going to fall in line. Doesn't necessarily mean that. If there is an issue with another system or console or whatever, that position can still pull no.
Right, but you are real time, Chris, at the Space Center. So this actually might be the other way around. You're going to see if they pick up faster than we are. So you may get a couple seconds extra warning.
So
yes,
if you
indeed.
see a clock start moving, feel free to yell.
I think I will. Yes.
Really quick, I'm going to keep going while we're still waiting for that final hold to actually be released. I'll try to fill in with some more questions here. Chat's got a few.
Actually, we forgot to
go ahead.
finish answering one.
Did we?
Yes, when all this polling started, we were in the middle of answering the question, can SLS take more to orbit than the shuttle? And I said, depends.
Oh, right.
If we go for deployable payload, yes, SLS Block 1 does win with 95 metric tons. The shuttle had about a 27.5 metric ton capacity for deployable payload to low Earth orbit. But the reason this becomes tricky to answer with the shuttle is you were also inserting the 78 metric ton orbiter into orbit as well. So technically, the system could get 78 plus 27 metric tons into orbit. And I believe it's very comparable to SLS in that regard, maybe a little bit more, maybe a little bit less, depending on the inclinations you're going to. But the orbiter makes that a tricky thing to answer because technically the total mass inserted is very similar, but the deployable payload was not. So hopefully that answers your question.
Right, and there's still a little bit of an apples to apples question or apples to apples comparison, but it is the closest comparison is to look at inserted mass and into this sort of suborbital trajectory.
Yeah.
So you could include the empty external tank, and again, we're also talking about when the core stage cuts off, that's an inserted mass that includes the empty core stage plus the Orion plus the fully loaded ICPS, and so another thing that's happening with the core stage is it's inserting into a much higher apogee, so it's a more elongated, a higher eccentricity. Even though the orbit, the low end is suborbital, it's got a more eccentric orbit because you've got a higher apogee, but it's still in the same ballpark. You're still talking about the shuttle orbiter is a large mass, and you also have again you have this suborbital, but just slightly suborbital insertion orbit.
Yeah, it's also worth mentioning that for example, the mass that the shuttle could deliver to lunar orbit was 0, you know? Like, SLS isn't designed for low Earth orbit, so comparing mass to orbit metrics is already kind of weird in that sense.
Right.
The core stage, I mean, look at the flight profile for Artemis 1, for example. Core stage could reach orbit, you could drop off the solid rocket boosters on the way to space and then insert the entire core stage and above stack into orbit if you wanted to. You would never do that, but you have to fly it kind of weirdly to prevent that from happening because the whole rocket is designed to actually launch things to the moon.
And to be fair, for like that comparison of like how close to orbit the core stage and by extension the shuttles and the external tanks, it's a very similar insertion profile at first for them. But I mean, like, yeah, you burn those RS-25s 1 second longer, you are in a full stable orbit.
Right.
Cut them off when you do, and you're in a roughly 66 by 250 kilometer orbit, right? Where your perigee is still low enough in the atmosphere to ensure that the stages come back in and are destroyed. But yeah, burn them for 1 second longer and you are in orbit.
Right, and so to compare the orbit that the core stage cuts off at nominally would be 40 kilometers by 1,800 kilometers.
Yeah.
And another, and then so it's a slightly different orbit.
Anyway, some more questions that have also come in here. Enraged Bacon says, what are the black squares on the boosters and center booster for? Those we talked about a little bit earlier, but if you missed our discussion, those are optical markers that'll help tracking cameras track especially the motion of the solid rocket boosters after they separate during launch. It's basically just references for comparing the imagery after the launch.
Basically, make sure it moved the way you thought it would move.
Right, yeah.
Right.
Yeah. And,
which means we expect those markers to probably go away after Artemis 1, right?
No. I believe some of them
eventually
will remain on Artemis 2 and maybe 3, but eventually they'll go away, yes.
But eventually, okay, gotcha.
Yeah. But we'll still see them for a while.
Gotcha. Sean with a super chat, no message, just saying thanks, so appreciate that, Sean. And Harry with a new membership, welcome to the club, and thank you for the support.
Oh, I remember what I was going to say, just in terms of velocities here, as a comparison. So, the core stage for SLS, the core stage cuts off for the Block 1 vehicle, orbital velocity is approximately 8 kilometers a second for this low Earth orbit, insertion orbit. The amount of energy it requires for ICPS to make the vehicle orbital is only 40 meters per second. So that's basically that little bit of additional energy that would be required to put the vehicle into orbit is 40 meters out of 8,000. So it's not that much.
Which is like an RS-25 sneezing.
Right.
Like, is
It's
40
just
meters per
right.
second.
It's like you said, just not shutting it off like a half a second later.
Also, another membership, Patrick Hagerty with a new membership. So thank you so much for joining on, and hope you enjoy your perks there. And again, just a thank you to everyone who tunes in and shows support for what we do. We appreciate that. Still waiting on another update from NASA regarding the polling that is ongoing for entering terminal count for today's wet dress rehearsal testing. Again, this is the first ever SLS rocket that will eventually launch Artemis 1. Today is the fueling test, the wet dress rehearsal, to test not just the rocket, but all the ground systems as well as the teams themselves. And the mission management team has pulled go for terminal count. However, there are other teams that also have to pull go, and we have not heard about those polls yet. We have also not heard whether or not, what the actual timeline to release the hold will be. It should be soon, but we're still waiting to hear the actual plan there.
Right. And then just again to overview for those of you who are just joining us, they've consolidated the 2 terminal countdown runs down to 1. And this one run, instead of going down to only 33 seconds, is going to go all the way down to 9 seconds. If they're, fingers crossed.
It is hoped to get there.
Right.
Yeah,
Because
there's
of the hydrogen
a
leak.
lot of sequencing
Right.
to
But
get
because
through
of this
here,
hydrogen leak, the vehicle's not in a normal configuration, and there's a possibility that we'll stop before we get all the way down to 9 seconds.
Yeah.
Well, I'll keep questions coming until we hear from them.
Please do.
Josh was saying, where does the hydrogen and oxygen for SLS come from, and how do they get to the pad?
Well, they come from a few different suppliers. I believe the supply of hydrogen primarily comes down from South Florida, primarily down around the West Palm Beach area, where it is manufactured, or rather, where the hydrogen is liquefied, and then it is transported through tanker trucks up to the Kennedy Space Center, and then put into the currently the one liquid hydrogen storage sphere at the pad. Liquid oxygen goes through a very similar process for its creation and then delivery. They come in waves of tanker trucks, and that's basically how they do it. It's tanker trucks, and you do lose some of the commodities to boil off while they are being transported in the tankers and while they are being transferred between the tankers and the storage tanks here at the Kennedy Space Center. And the storage tanks actually lose. They lose about 600 gallons a day to boil off on the oxygen, and it's a little bit higher on the hydrogen side than the oxygen side. It's a little bit higher on the hydrogen side than the oxygen side, but the spheres do a pretty good job of equalizing that. But you do lose quite a bit to boil off, even during the day, in those storage tanks there at the pad. But that's the answer to your question of where it comes from and how they transport it here.
That's not too bad, though. 600 gallons out of, I think they have not quite 800,000 gallons usable in the liquid hydrogen sphere. So that's not too bad, considering
not at all.
Considering how cold liquid hydrogen is.
Yeah, and the storage spheres are actually a pretty interesting story. We have a written piece on this from the first time Artemis rolled out to the pad back in March. If someone can find that article from March 17th from myself and Nathan Barker, we talked to the pad guys about this, and specifically the liquid hydrogen systems. And with the upgrades and the modifications that they made to the hydrogen and oxygen storage spheres at B after the conclusion of the shuttle program, they are actually doing better than their original design specifications from the 1960s in terms of how much they lose each day. That wasn't always the case. There were prechlorate voids in both of the storage spheres at 39B, and this basically resulted in losing 1,200 gallons of liquid hydrogen a day to boil off. And then after the end of the shuttle program, they were able to find that void issue, fix it, refurb the tanks on both the oxygen and hydrogen sides, and now they have that boil off rate, the rate that is lost per day from the spheres, down to even better than what it should have been in the 1960s originally. So probably more than you wanted to know. But yeah, once the second hydrogen sphere is done, that's a 1.2 million gallon liquid hydrogen sphere. Once that is done and fully filled, there will at all times be 2 million gallons of liquid hydrogen at Pad B for the SLS rocket.
There you go. Another super chat that has come through here. C. Newton says, just crazy how different the approaches to rocketry are. This uber methodical SLS NASA methodology, which most rocket companies continue with, versus SpaceX's design, test, fix, innovate, iterate, repeat process. Thank you, Newton, for your support, and definitely an observation that we've seen many times, especially recently, comparing some different ideas to how to get rocket engineering done. And there's always multiple ways to get to solutions to the same problem, but it's always an interesting discussion to talk about that, and SLS is definitely a prominent example in that discussion.
Definitely the influence of the internet and software development evolutions.
This is Artemis Launch Control at T-minus 10 minutes and counting with an update. The engine bleed valve on the liquid hydrogen side of the core stage has been closed. That is to prevent the flowing of a hydrogen bleed through that leaky, quick disconnect. So again, this is a requirement in order to pursue a T-minus 10-minute terminal count, and that valve has been closed.
He said counting, but they're still holding. I think
they are indeed holding, yeah. Okay, well, then there we go. So the teams are basically just configuring SLS now into its off nominal configuration to be able to get into this terminal count. Clock is holding at T-minus 10 minutes, awaiting its pickup for the actual terminal count run.
Yes.
And terminal count basically just means there's no more planned holds. It's now to the end. Like, we are actually, like, it's not just fueling the vehicle, it's making sure every single blade of grass is aligned so that we can lift off. Of course, we're not trying to lift off.
We are expecting the poles in about 5 minutes. We've got 2 poles. One is the NASA Test Director pole.
Okay.
That will then feed into Launch Director Charlie Blackwell Thompson's pole. And once those poles are complete, we'll begin terminal count. So it looks like we've got 3 masks to the ground launch sequencer in order to get through terminal count. And the team is working to configure the computer so that they can go forward. This is Artemis Launch Control.
Cool. And just to quickly finish that thought that I was saying before Daryl's update there. So terminal count is basically there are no more planned holds. We are going to attempt to lift off, like get to the culminating point of the countdown. At that point, it's easy to find terminal counts in countdowns that have holds, like SLS and Atlas and Delta. If you are more familiar with SpaceX launches, the term terminal count is more known to you as auto sequence, which is essentially the same thing. It is the point at which you are trying to commit the vehicle to liftoff. and things like that. But that's what terminal count means. It has no nefarious meaning based
Right.
on the first word in its name. It's just the end.
Yeah.
Right. And you guys, since I'm surrounded by SpaceX people, as always, correct me if I'm wrong, but when they talk about the Falcon going into startup at 1 minute, that's kind of analogous to the T minus 30 seconds point here with this vehicle when the flight computers go on their auto sequence.
That is
Yeah.
exactly correct. Yeah, 60 seconds is when the ground computer hands off to Falcon 9's computers.
Right.
Yeah.
So the 30 seconds would be the analogous here for when the SLS goes into startup, essentially. And so we would get, if they can make it all the way down there, we would get into a pretty busy sequence. So some of the stuff that they do inside 30 seconds will be those booster hydraulic power units that we've been talking about. Will start
NASA
up.
test director is now conducting his poll.
That's Jeff Spalding, who you'll shuttle watchers will remember, will recognize his voice when we get to launch day.
Oh yes.
But this is his. I believe he was in this same position for the last.
The NASA test director has completed his poll, and everyone is go for count. Charlie Blackwell Thompson is now conducting her poll.
All right, 2 polls down. The last one.
She's
to
polling
go,
the chief
but everything goes
engineers.
So far.
They are go.
We should pick
She's
up pretty
polling
quick.
EGS chief safety officer. Safety officer is go. Range weather is go. Mission management
be a lot of waiting
director
around
Mike
after this
Serafin
poll.
is go. Charlie Blackwell Thompson has given the go to proceed with terminal count to the NASA test director.
Good.
So I will not be surprised if we pick up here real quick.
We are going to resume the clock at T minus 10 minutes momentarily.
They are counting T minus 9 minutes 52 seconds and counting according to the clock at the press site.
All right. Okay.
All right, we will see the official NASA clock on your overlay update shortly. But Chris down there in person at the press
Countdown
site
clock will
reports that
resume.
the clock has resumed.
Now.
And there you have it. There is your updated clock. Under 10 minutes to go. This is the first
Terminal
time
count
that a
has
fully
begun.
assembled SLS has entered terminal count.
And we're probably going to be talking around Daryl here because we want to make sure.
The ground launch sequencer mainline has been initiated.
Good. That's exactly what we want to hear right now. Basically what that means is that the ground launch sequencer is controlling everything right now. And the clock at Kennedy is at 8 minutes, 57 seconds and counting.
Our plan T0 will be 7:37 p.m. Eastern Time. T minutes.
We won't
T
quite
minus
get there.
9 minutes, 20 seconds and counting.
The next sort of major point is T minus 6 minutes. And so there will be, that's I believe one of those milestone points. And so, 6 minutes will be when we start.
Yeah.
Hearing whether things are going smooth, whether they're going to continue.
And we do know that there's a slight visual difference today that they did not pull the crew access arm back, and there is no plan to pull it back. So it's not like at T minus 6 minutes when it would normally retract if crew were here. We are not expecting that crew access arm to move for the test today. And the countdown clock at Kennedy is at 8 minutes and counting.
So NASA gave us a pretty good reference.
The terminal count underway. The ground launch sequencer is monitoring and commanding.
So at 6 minutes, Orion would go to internal power, and then shortly thereafter, we would typically we would get the core stage LH2 tank. They would terminate
T-minus
replenish.
8 minutes and counting.
So we're still a couple minutes away from that.
Again, that other voice you're hearing is Daryl, which is a NASA public affairs officer who is providing the update straight from mission control. So you're hearing his voice
Right.
every once in a while.
All right. And our countdown clock here at Kennedy, without the time difference,
The
is
launch
at
team
7
is highly
minutes and
focused.
counting.
It is extremely quiet in firing room 1.
And he was
Thousands
talking
of
about
operations a second happening right now.
Man, it's not even launch day, but my stomach is in butterflies because we're in terminal count.
Yeah.
Like,
Imagine what it will be on launch day.
T-minus 7 minutes and counting. The count proceeding nominally. No issues, no flags.
good.
the
All right,
specific
yeah.
point that he the specific point that he was talking about, that where we might see something, would be 4 minutes 40 seconds. So
Yeah.
we'll see.
Yeah, and Philip, you were okay.
At T-minus 6 minutes, the ground launch sequencer will give the go for core stage tank pressurization.
And it is 6 minutes 5 seconds on the clock right now.
At 5 minutes, GLS will give
Past
go
6
for
minutes.
flight termination system arm.
Okay, well, we passed the critical T-minus 6 minute mark. So SLS's core stage tanks are pressurizing for flight at this time.
That'll be the hydrogen side. So the oxygen side will be beginning at T-minus 4 minutes.
Okay.
T-minus 6
Copy
minutes.
that.
And we are go
And
for
again,
core
Chris is-
stage tank pressurization. This brings the tanks inside the Space Launch System to flight levels.
And again, Chris is there in person.
Next
So
milestone,
he's seeing the countdown clock.
T-minus
slightly
5
ahead of us.
minutes. GLS will give a go for flight termination system arm. This will align the firing chain so that in case of an anomaly in flight, the vehicle could be destructed.
And we have passed 5 minutes successfully on the countdown clock, and we are at 4 minutes 55 and counting here at Kennedy. Again, my countdown clock's a little earlier.
Right. Just a sanity check. You can see that the core stage liquid oxygen tank is still venting, and so we should see that venting stop at 4 minutes. They'll close the vent valve at that point, or somewhere around there.
T-minus 4 minutes and 55 seconds, and the go for FTS arm has happened.
And that might be partly simulated, since we don't have a fully end-to-end connected system for the flight termination system.
We also passed the moment at 4 minutes 40 seconds where they thought the system might kick them out.
GLS is now go for LH2 high flow bleed check. This has been masked.
The clock is still running here at Kennedy. We're at 4 minutes.
Ground launch sequencer continues with the count. No hold.
You should see the venting stop on the core stage.
Yep, we have just passed 4, so core stage vent
T-minus 4 minutes.
Yeah.
We'll get the go for core stage auxiliary power unit start.
Right, and that's also the time. And that's a helium spin start system as opposed to self-contained units like it used to be.
And we have go for LH. We have go for core stage APU start.
Good. We're under 3 minutes 30 seconds on the clock at Kennedy.
Next milestone, T-minus 3 minutes and 10 seconds. We're looking for a go for purge sequence 4. This is the final helium purge of the engines.
Countdown clock has passed that milestone successfully that Daryl just talked about.
Not sure we're going to see the engine gimbal profile or not. That would be at 2 minutes 30 seconds. I hope they switch back to that camera at some point in that.
All right, on the countdown clock at Kennedy, we're at 2 minutes 45 seconds.
GLS is go for purge sequence 4. Helium is now purging the RS-25 engines.
I'm serious, guys. I've got goosebumps, and I know it's
Next
not leaving
milestone.
the pad or lighting it.
And it's not even going
T-minus
anywhere.
2 minutes and 2 seconds. Go for upper stage to internal power.
All right, 2 minutes 20 seconds.
This
on
will
the clock
switch
here at
the
Kennedy.
ICPS to its own battery
we'll
power
see.
from off of ground power.
We'll see if they do that test objective. Because again, I said I'm not sure if we're going to see them hold at 90 seconds or not. I will not be surprised if they just continue down.
Yeah. Countdown clock is under 2 minutes and counting. Guys, if they can make it through terminal count in one go, this is a huge win for this team here and the SLS system.
Yeah. And if they can do the handoff at 33, that will also be a big
We are
milestone
go
for
for
them.
upper stage to internal power. Next milestone, 1 minute 30 seconds. Go for core stage to internal power. This time it will be the core stage, which will switch to battery power off of ground.
So they did not do the hold objective, Philip. They passed 1:30 on the clock here.
Right.
We are at 1:15 at Kennedy.
We'll see what happens at 33.
Okay, I'm going to stop commenting on what the clock is because we're at the point now where that's just getting confusing.
GLS is go for core stage to internal power.
Thank you, Chris.
Flight control room 1 is dead quiet. Next milestone, T-minus 1 minute. As planned, a flag has come up, but it was masked. The GLS continues. At T-minus 33 seconds, we will get GLS go for ALS. This is switching the ground launch sequencer to ALS.
And we are holding at T-minus 29 seconds.
The go has been given for ALS.
Okay.
Cutoff. At T-minus 29 seconds, we have a hold and a cutoff. Vehicle safing has begun.
Look at the flare stack go.
Yeah, I saw that.
Yep.
It's been a while since we saw a flare stack react to testing, but not the first time we've seen that ever.
But totally normal.
Yep.
All right.
Folks, go ahead, Chris.
Yeah. So
core stage APUs, the auxiliary power units, have been shut off.
Right. They're going into the automatic safing.
And recycle. So we did have a handoff at 33 seconds, and then the countdown clock stopped at 29.
Hydrogen tanks
failure.
Did they say what it was?
They have not said yet, no.
LOX tanks, currently working to determine.
But just to be clear, this was not the plan. The plan was to count to 9 seconds and cut off, not 29 seconds.
Right.
So there was something that flagged in. At that point, it could be either the GLS or the it was ALS or GLS.
GLS primary safing is complete.
The automated launch sequencer starts at the analogous to startup is at 30 seconds, and that was one thing I was wondering was, you mask all of these things off in the ground sequencer up until that
all
point.
APUs
but
are shut off.
Can you do that?
Transferring to ground power.
Flight computer system. Can you mask all of those? Because the vehicle's looking at all of it. The vehicle takes over the red line monitoring essentially, and so I don't know whether they can mask that in the flight computers or not. So we'll have to ask them tomorrow. If hopefully they're going to do a telecon tomorrow, we'll have to ask them.
Yeah. But let's just briefly recap, and I'll pause as soon as Daryl comes back on here. But the Artemis launch teams picked up our count at T-minus 10 minutes and counted all the way down to 29 seconds. No issues in the terminal count until the handoff from the ground computer to the flight computer. That is a very, very
Launch team is
important
currently
and a huge
going
win.
through their procedures to safe the vehicle.
And an absolute huge win. What it shows is that all the critical systems to get the vehicle to flight configuration worked. Everything
Propellant
sequenced
teams
properly.
verifying no leaks on the tanks.
Nothing was out of alignment in that system. What happened? So at 33 seconds, the ground launch sequencer hands off to the SLS's onboard flight computers. And it was right after that moment, 4 seconds later, at T-minus 29 seconds, after Philip was talking about how the automated sequence begins, right around 30 seconds. At 29 seconds is when something in the system flagged that there was an issue, issued the cutoff order appropriately, and the system responded as it should have by stopping the clock, stopping the count, and then the teams got into safing the vehicle, which is what you've been hearing Daryl reporting on, with the various systems being shut down and leaks being checked for and everything like that. Of note, that was not the plan. The plan was to go to
Launch team
9
now
seconds
safing
and
the
cut
flight
off.
termination system.
Right.
So
This
we
is
will
standard.
wait to
They recycle. They basically take the vehicle back to a known stable point, which is sort of the T-minus 10 minute configuration, and they're continuing to do that now.
Yeah. But as Philip was saying, it's easier to mask and sort of hide off nominal situations from the ground computer, but you don't necessarily want to do
Safing
that
of
to
the
the flight
ground launch
computer.
sequencer is now complete.
And so we'll just have to see, because both systems, the flight systems and the ground systems, are continuing to execute the red line monitoring. And either one of them could have flagged something, and so that'll be a question that we'll have to find out is, was that, who called that one?
Yeah,
Considering
because
the
very important.
timing, it's you would think it's probably the ALS, but we won't know till tomorrow. Well, unless they tell us.
Yeah, because there's a tendency here to go, okay, we were expecting an issue, we had an issue, it must be that issue. That's not necessarily what happened. This might not have anything to do with the bleed valves being closed instead of opened, might not have anything to do with the engines themselves. It's possible, but it's not a guarantee, right? There could have been something else that flagged in the system that caused ALS to say no. Automated launch sequence to say nope, not proceeding any further, and it has nothing to do with the issue we were expecting. That does happen sometimes, so just let's wait until we hear Daryl say exactly what it is or get that information in the briefing before definitively saying one way or another what it is that kicked them out after the handoff to SLS's onboard computers.
Launch team continuing to safe the vehicle and go through their procedures, which will eventually lead to a detanking of the rocket. I want to clear up a couple of things. We did not get down to T-minus 9 seconds, and that was because of a late change. The team expected the ALS, the internal computer, on the SLS, the Space Launch System, to cut off at T-minus 29 seconds because it saw a flag that triggered the cutoff.
That's an interesting statement. Let's see if he comes back and clarifies that, because kind of a contradictory thing there, and he's listening to a whole bunch of different things, so this is not a complaint against Daryl. He seemed to indicate that this is exactly what the team expected, but that's not what the expectation communicated outward was. The expectation was to go to 9, not to stop at 29. He then indicated that this is what the teams expected all along, but then he said it stopped because it saw a flag in the system, but he didn't say it was the expected flag that they saw in the system. And again, those two statements are a little interesting, because if the team was expecting to cut off for the ALS, the onboard flight computer, the automatic launch sequence, to cut off at 29 after it assumed control, that is not what was communicated out to everyone as the expectation. So we'll have to wait and see exactly what that is.
This is Artemis launch control. The team currently actively safing the vehicle, working through their procedures. That is the highest priority at this moment. We don't know exactly why the ALS cut off at 29 seconds, but
there we go.
It doesn't matter because they've got some critical operations to conduct right now. Once those are complete, they will be able to look and see exactly what the flag was that caused the cutoff. Ultimately, the team wanting to get down as close to the end of terminal count as possible. The plan was initially for 9 seconds, but the expectation was that it would cut off after the ground launch sequencer transferred control to the rocket. It was several seconds after that happened, at T-minus 33 seconds, that it then cut off. 4 seconds to be exact.
Probably what...
Again, we'll get more information on that in the debrief on what the exact flag was for cutoff.
Yeah, go ahead, Philip, and then I want to sort of make a statement about why they don't know yet.
In safing the vehicle and preparing for detank.
I think probably what it amounted to was, they weren't necessarily sure what would happen after they handed off to ALS, and it's possible that as they continued to look at it, before they talked for quite a bit of time there before they picked up, and I think probably by that time they looked at it and went, well, probably what's going to happen is we're going to kick out pretty quick after ALS starts, but he then, like you said, it's a little confusing because he says they're not sure, but again, I don't know how much assistance he's got in the firing room in terms of people who've got additional ears that can be listening to the integration console loops or some of the other loops. So we will have to get some clarification on that.
This is Artemis launch control. Just a few more minutes left as the team continues to safe the vehicle.
So let's talk a little bit about Daryl saying that no one has been briefed on what kicked them out of terminal count yet, and what kicked them out of the auto sequence. That is not to say that nobody in the firing room knows why they got kicked out. Right? There is a team in a console who saw that flag flash across their screen and absolutely knows. But here's what happens when you cut off a countdown that close to liftoff. Your immediate concern from the launch team is, we don't care what cut us off unless it is a threat to the physical safety of the vehicle or the lives of crew who are on board that vehicle, right? Then you will hear very quickly what the reason is, because it might necessitate a very different set of procedures, right? If something is very critically wrong and the vehicle is in a condition or a state where it could disintegrate, right, or explode. So if you do not have an immediate threat to the vehicle or to lives on board, then to the launch team, it doesn't matter what kicked you out. You have a critical sequence of steps that you have to follow to get the vehicle back into its safe configuration. And this is very similar. If you go back and you listen to some of the on-pad aborts from the shuttle program, you will hear them call out the engine shutdowns. You will hear them.
This is Artemis launch control.
Yeah, and you would, but basically you would hear them.
We have an update. The critical portion of the safing of this vehicle is complete. Flight Director Charlie Blackwell Thompson is currently headed over to the mission management team to discuss that terminal count run.
Turnaround.
We're going to have her
Yeah.
come over and make some comments
Okay, that's good.
before we wrap up
Yes.
our coverage here,
Good.
so please stand by.
Good. Yes, talking
Right.
to Charlie is always a good idea. Yes. So anyway, if you go back and you listen to old shuttle pad aborts after the engine's lit and shut down, you can hear them go through all of their safing, and it isn't until they are completely saved that they then stop and go, what caused it? And sometimes even at that point, they're just like engine 2. Like they don't know more, but it's not the launch team's desire to figure out in that immediate moment what kicked you out, what stopped you if there's no threat to the vehicle. Get it safe, and then you can figure it out, which is what Charlie's doing right now. And also talking about the turnaround time, because I have a sneaking suspicion we're going to have to redo this. But yes, this is also good too, and an unexpected cutoff at an unexpected time is also good, because this could happen on launch day, right? Where you could cut off at any second after 33, and the team needs to be able to instantly spring into action and work through these procedures. And you can train and you can sim and you can do all of those different things. There is nothing like practicing that procedure with a fully fueled vehicle out on your launch pad to really hone your skills. So getting the team that practice of getting kicked out of a terminal count unexpectedly and having to recycle the vehicle, which is basically what they have done here, was a major test objective that they would have achieved even at the planned cutoff at T-9 seconds. But because this came 20 seconds earlier and somewhat of a surprise, that's good for the team in exercising their abilities to handle those situations and move immediately into safing procedures when not expected.
Right, and then you may they may, if this really was a surprise, then it may have uncovered something that it gives them something else that they can prepare for, either after wet dress or for launch itself. And so it's another learning experience they can get if assuming that this wasn't expected. And so we have to wait and see if that's the case. Now, like in some of the support centers, like for instance in Huntsville, those people are specifically looking at SLS systems, and I'm sure there are also people in the firing room. But as Chris said, your priority when you have a cutoff is to get the vehicle and the ground systems into a stable, safe configuration, and that takes that's your focus. And until you reach that point, they continue to work on that, and it's not time critical for them to know whether to look at what the issue was and to troubleshoot it. It's time critical to get into a safe configuration first.
Indeed it is. Well, so yeah, I mean, overall today, this was incredibly successful. I mean, let's break out of that for a second and talking about the challenges they faced today. Let's talk about the fact that they got to 29 seconds. They achieved almost all of their objectives. They didn't hold the count and demonstrate that. But inside of terminal count. But on the grand scheme of things, that might not be something that you need to come back and redo. They demonstrated the ability to take it through the terminal count, through the handoff from the ground to the flight computers, which was great. And then the flight computers had 4 seconds where they were in control of that vehicle before they flagged something in the system that went, whoa, not right, stop. And that's good. I mean, they got to 29 seconds on the 4th attempt with this behemoth of a vehicle. And we talk so much about like the shuttle heritage hardware, but we probably should have done a better job of saying like, but this is a brand new vehicle, right? Yes, it's got the heritage. Yes, the boosters are essentially shuttle boosters with an added segment. and you've got the RS-25s. The core stage is its own animal. The ICPS is its own animal, different from the one that launches the Delta IVs, right? The fact that they took this combined vehicle all the way down to 29 seconds is a huge win. And if they come back now, having counted to 29 and say, okay, like, we got what we needed from the wet dress rehearsal, we think we're okay to proceed to launch. Again, that is massively dependent on what kicked them out at 29 seconds. But this is big. This is a really good day for SLS, for the teams, and everyone who has worked on this vehicle for over a decade. This was a really good day for them. And we are much closer to SLS's first liftoff than we were when we woke up this morning. So this was a good day. Very good day.
Right. And I mean, yeah, just consider how much of the tests they completed today compared to the first 3 attempts. So they got the vehicle completely loaded. They got into stable replenish. And they got, like you said, they got basically through the entire ground controlled terminal sequence. So that's, and I mean, the flight computers are participating in that. They're just not the ultimate authority until 30 seconds, until 33 seconds in this case. So, but the all of the actions that the ground launch sequencer asks the vehicle to do, it basically tells the flight computers to carry out this command, and the flight computers then do it. So now with the ground systems, there's not necessarily a go-between.
Right. And that's important, right? Because like what you were just saying, right? Like from 10 to 33, the ground launch sequencer is in control with the flight computers monitoring everything. And they can still flag things and say, whoa, something doesn't look right, and flag it for the GLS, but the GLS will likely catch it as well, right? GLS ground launch sequencer, ALS, automated launch sequence, SLS is computers. That's that. And then at 33, the roles kind of reverse, right? And the GLS is still controlling the ground side of things, and it's monitoring the vehicle side, and it can still flag things that it sees that are wrong, but it's not the ultimate control authority at that point. It's SLS's computers after 33. But they still work together right up until T0.
Right.
At which point the ground launch sequencer takes back over to start safing all of the ground systems as the vehicle is lifting off.
Right. And you have this sort of split, it was the same in shuttle.
Right.
The ground launch
This is
sequencer
Artemis
still
launch control
gives a go to start the
at
engine.
the completion of wet dress rehearsal for Artemis 1. I have joining me Launch Director Charlie Blackwell Thompson. Thanks for being here.
Why, thank you. It's my pleasure to be here with you this evening.
Well, that was exciting.
It was definitely exciting. It's a great day for our team, and really proud of them working through the loading operations and working through terminal count. So definitely a good day for us, and a very exciting day as well.
So in following the launch team, you could tell there was this desire to get into terminal count. Tell me why that is.
Well, terminal count, there's a number of functions that we go through and we test as part of that final readiness for launch. And we have done this many times in a sim, but we haven't done it with cryogenics on the vehicle. And so today we got all stages to replenish. That was a big milestone for us, getting both core stage and upper stage into replenish. And then our team really wanted to get into terminal count and work through those milestones and see how we performed, how the team performed, and how the hardware performed. And they both performed very well.
Now, in that moment, you had to make that decision and that recommendation to go forward when you were told that this was going to flag the ground launch sequencer, and that it would have to be masked, basically not see a state that it was not supposed to be in with regards to that liquid hydrogen bleed valve. What are the consequences of doing it, kind of going through that and kind of having that computer be blind to that?
Well, we were always protected in the flight software, so we knew that we had protections there. We also had the team that was monitoring for any anomalous conditions, and I have ultimate faith in our team to be able to make those determinations and make those calls to cut off if we need to. So I felt like we were in a really good configuration to continue, and again to get into terminal count and see how the hardware performed.
You had a fully fueled rocket out there, fully tanked.
Yes.
What are your thoughts on that personally for you?
You know, I've been working on this vehicle and these ground systems for a really long time. And our team's been working on the software. You know, we had some challenges in wet dress 1 through 3, and getting both stages to replenish is a big milestone for us, big milestone for the team. And for me, I just had a huge sense of pride as the team worked through that, and knowing the work that they did coming out of wet dress, 3 especially, and getting ready for 4. So just really proud of the team and all that they've done to get us here.
And they put in a long day, as did you. So tell me, what's next? You're going to evaluate a lot of data, I take it, but then what's the next step for the Artemis launch?
Well, like any test we run, we'll go take the data. We'll go look at what we got. We'll go look at the couple of things that we didn't get, and we'll lay out a plan for how we go forward. Probably a little premature to answer tonight after a long day, but certainly tomorrow we'll be back at it, and we'll be looking at the data and laying out how we proceed forward.
All right. Artemis Launch Director Charlie Blackwell Thompson, thanks for coming over and taking the time, and get some much needed rest.
Thank you. It's my pleasure to be here. It's a good day.
Thank you. No doubt. And that will conclude our broadcast here at the Kennedy Space Center. Again, we had ALS cut off at T-minus 29 seconds, and that completes the wet dress for today. Look for a press conference to be scheduled for some time tomorrow. Stay tuned to NASA's social media channels and our webpage for more information on that. For now, though, for all of us here at NASA, I'm Daryl Nail with NASA Communications. Thank you for watching and joining us. Have a good night, and remember to keep looking up.
All right, so that wraps up NASA's official coverage of today. Of course, we're going to stay on just for a little bit and wrap up what we saw today. Let's start with Chris. What are your thoughts on Charlie Blackwell Thompson's and ending comments there, and where we stand towards completing pre-launch testing for Artemis 1?
Yeah, not a Charlie's comments not a surprise at all, based on what she said and the competency and praising of her teams and where they were. It's always nice to get to hear how calm a launch director is, because it helps calm you down from sometimes for things that can get your heart going. But overall, I think she's right. Like it's a bit too early to say. Do you? I mean, I know I have my personal opinion. Do you have to redo this? Do you? And here's the other thing: they might not have to redo this, but they might opt to redo it just to get the teams a little more practice. Go through it again, see if you've got the issues figured out. But a lot of that balance will come down to how can they fix the liquid hydrogen leak, right? Because I'm sure in an ideal world, they would love to redo this again and just go through it with no issues, right? And really get the system tested in that configuration. But we'll have to see what their forward plan is, because as Charlie mentioned, there were only a couple of things they didn't get. And from what they sort of said previously, that demonstration of hold capability for a prolonged period of time in the terminal count, I believe it's about 3 minutes is how long they want to hold there for. That they didn't get, and they didn't get all the way down to 9 seconds, right? So there were a few other things in the terminal sequence after 33 seconds that they didn't get. But other than that, it looks like they got a lot of it, or the rest of it. So that's great. I mean, in terms of where we are for readiness to launch, I mean, I would honestly say after today, that second window in August, the one that's fully in August, is most likely still the no earlier than possibility for what they can achieve. Nothing here today is necessarily a showstopper to that, unless they really want to fix the liquid hydrogen leak and redo this, and it just takes them a while to fix the liquid hydrogen leak. But we will note, again, the original hydrogen leak that happened on attempt number 3 that they came back to the VAB, realized that they hadn't tightened or torqued the bolts, so they redid that. That worked. That did not leak today. It was a totally different part of the system's quick disconnect that leaked today. So that is good. That means the previous issue was fixed and we found a new one. So overall, this is extremely positive for SLS.
Philip, your thoughts?
Well, I mean, I think I agree with Chris, and I think there's a couple of things I would note. That 3-minute hold demonstration, they did a subset. They did a 3-minute hold demonstration at Stennis, and I mean, in terms of the complexity of this launch vehicle, the core stage is most of it. So, I'm not sure that's a showstopper. I think they didn't get to do a real live recycle, but I don't know that that's necessarily a showstopper either. I think it's we had a little discussion about risk reduction and buying down risk, and I think they're going to have that discussion again at some point after they review this, which is how much additional risk can we buy down doing another test attempt, and do a risk benefit comparison. Is it worth the risk, or not? So but I agree. This has been a good day. They accomplished a lot of the probably the balance of the test objectives, and it'll be interesting to see what they decide, where they decide to go from here, whether they want to tank the vehicle here while it's out at the pad again, and do this troubleshoot that leak, or whether I when I heard this plan, my initial thought was that these are steps down the road of maybe the next time we take the vehicle will be for launch. So it'll be really interesting to see what they decide to do.
So there we go. So everyone, just to recap what we saw today, thank you, Philip and Chris, for all of your insights and analysis. Wet dress rehearsal got all the way down to T-minus 29 seconds. What we're going to expect to hear starting tomorrow is some further updates regarding the NASA team's plans going forward, the possibility of doing another wet dress rehearsal to iron out some of the small issues that they did not iron out today, or simply to give the teams more experience or get a little more confidence before the launch attempt in later this year. That's definitely on the table, but it's also possible that NASA could conclude that they have the data they need. So we're going to wait for more updates, and of course, NASASpaceflight will be reporting on the plans that get made once they are available. But everyone, so far, just thank you so much for tuning in to our live coverage of the wet dress rehearsal, another big step in the direction towards launch readiness for Artemis 1. I want to go around the horn and thank the NSF team that brought you this coverage. First and foremost, out there in the field was Chris Gebhardt, Assistant Managing Editor for NASASpaceflight. And Chris, thank you so much for rolling out there and bringing us a camera view in addition to all of your commentary and insights today. Thank you so much as always.
My pleasure. Great to be here.
And also Philip Sloss, who is our resident SLS writer. He knows the ins and outs of this program better than anyone else here at NASA Spaceflight. Philip, thank you for offering your time today and all of your help.
Thanks, it's been fun.
All right, and everyone, a big shout out to Patrick Calhoun. I hope I got your name right, Patrick. I'm sorry. Was pushing the buttons and pulling the levers in the back room to make today's stream happen. So Patrick, thank you for all your time today. Everyone, thank you all for tuning in, especially for those who sent in that extra support. We really do appreciate everyone who tunes in and supports what we do. My name is Thomas Burkhart, News Director for NASA Spaceflight, and bringing some commentary as well today. Again, everyone, stay tuned for future launch coverage as well as other spaceflight events around the country and around the world. From the Kennedy Space Center, this is NASA Spaceflight signing off. We'll see you all next time.
Propulsion continues to be normal.
RCP chamber pressure looks good. Throttling up.
Water towers can fly! Yes!
Echo Delta nominal.
Flight downside SCE to off. Say again, SCE to off. Off.
Yikes. You bet. Concur. We don't need any more of these.